Good morning, Internet. Good morning, Internet. I hope you're having a good day. Good start to your day. If you're not in America, you're probably well into your day by now, and you are doing all kinds of interesting things. Today, we are doing a hackathon. Well, the second day of a hackathon, and we're building an application called Braid. If you didn't tune in yesterday, you have absolutely no idea what any of this is, and that is absolutely cool. I've written up a little blurb behind me. If you want to go and check out the project as we go along, it's github.com/pp33f/braid. We are building a tool for a real tool that we need internally as Splunk/Cisco. It is a diagnostics tool that allows us to replay a conversation between a customer's browser and when they're using a web application and the back end, essentially, and what's going on the back end. We're trying to capture the conversation that happened, all the requests, all the responses, and then replaying that so we can see exactly what the customer saw. But we're going to be able to do a few more things as well by, like, for example, be able to navigate, look up, look through, search, and explore the HAR file. HAR stands for HTTP archive, by the way. And then we're going to be able to render it and then be able to use it as a dev server, like a mock server, but with breakpoints. That's the purpose. Yesterday, where we got to was we actually went through the whole design process for one major piece of the engine, which is, well, it's actually called the engine. It's called the horrific engine. The tool's called Braid. The reason why it's called Braid is because it's inspired by a game. Amazing engineer called Jonathan Blow created a game a long time ago called Braid. He's done some other things since then, but Braid is the one that stands out to me the most. Phenomenal game. It's all about time manipulation, and this is what we're doing here. So I thought I'd use the name. However, during the stream yesterday, it became a little bit obvious that, well, obvious to me anyway. It was obvious that Braid might not be the best name. It might not, because we've got Horrific, which is our engine. HARIFIC. Horrific. Horrific, not horrific, but that's the fun, isn't it? That's the play on the words, and I like that. But then again, it needs to be something that's friendly. Saying, oh, you're using horrific, it's like, well, what is that? Maybe that works. Maybe that's the hook. I said this, I said this yesterday, but there's two really hard problems in computer science and engineering. The first one is naming things. The second one is caching, and we touched both yesterday. We were naming. Well, we did name some stuff. Yeah, we did, and we did some caching as well. So we actually tackled the hard stuff up front, caching and naming. Excuse me, I'm just going to open this little can of water here. Makes like a fizzy sound. Sorry about that. I hope they didn't offend you, because some people might get offended. I don't know. You never know. I'm drinking water and coffee. I'm double fisting today. All puns intended, always. So, where are we going to start today? That's always the fun thing. What are we going to do today? So, yesterday, as I said, we built the Horrific engine, and the Horrific engine is really just a parser. It's a parser for reading in very, very large HAR files and being able to do effectively an index lookup. So we're going to look through the file, scan through it, pull out all the metadata, not the actual bodies, but the metadata. I'm not sure about that logic yet. We haven't tested it. Well, we have tested it. I tell a lie, we have tested it, or at least the tests have been written with dummy data, and it says it's amazing. We're going to look through that this morning. We're going to look through some of that code and determine whether or not it's actually doing what it says it is, or if it's just done that, hey, 1, 2, miss a few, 99, 100 AI trick that they always seem to end up at when they can't solve whole problems. I solved it for your quobix, and it hasn't really solved it, has it? What it's done is it's just bypassed all the logic and said, oh, look, the test passed now. So I hope we haven't got there today. I'm pretty happy. Before I do that, I just need to do some housekeeping and double check that I've got all my chat stuff set up. I've left everything from last night or yesterday, and I probably am missing stuff. Probably, I don't know, but let's go and make sure that I can see what's going on here. Keep session, yes. Sorry, what I'm doing is right now is I'm just looking at some YouTube stuff. I can't see it. I'm looking for chat and things like that. Here we go. You know what? I don't know what I'm doing here. It's auto-activating. See, it's got yesterday's chat in there, and I might need to go and restart all of it. Let's do that. Oh, I've messed it up. So what I'm trying to get is my social stream set up again, and it's gone a bit. There we go. It's found one live source. Okay, select live source. Great. And I need to bring up my streaming chat again. I think I've lost it. There it is. There it is. Let me just see if it's going to work. There it is. Chat's working. All right, great. New guest. Hi. I'm not sure if that's a real one or if it's fake, but doesn't matter. That was me just clicking it. I think I only clicked it once, but I might have clicked it twice. Anyway, I'm digress here. Thank you for bearing with me. Sorry, I'm all very new at this. I should have done my homework before I got set up here. Oh, and we got a friend. So one thing I'm not doing is I'm not giving out names. Just because I don't know who is so sensitive about names on the internet, because all this is very public. But this is part of a hackathon for Splunk/Cisco's where I work, and I'm building this tool as part of our hackathon. I'm super excited about it. I've been thinking about it for some time, and it's a real tool with a real use case, because we have customers that are complaining about our product, or one of our products called Enterprise Security, that is simply unable to say, like, it's all slow and it's janky. I'm like, okay, how do we fix that? How do we fix that? Here we got Vlad. We've got Vlad on the line, and Vlad is on YouTube. Hi Vlad, how you doing? Or Vladislav. I'm not sure if you prefer Vlad or Vladislav. I'm assuming you're in Poland. Maybe, maybe not. Anyway, thank you for watching. It's very early on the West Coast, so I'm sure no one else is alive or awake. I mean live. Oh, live, not alive. I'm sure everyone's alive. Hope everyone's alive, unless something terrible happened in the night and we don't know about yet, but I'm pretty sure everything's just fine. So back to the code. The most important thing, the har file engine, was yesterday. So I'm actually got, I'm going to just bring the code up right here. Let's do that. Here is the code, and I'm going to make myself a little smaller because I'm right in the way of everything. Okay, look, I'm out of the way now, so we can take a look at the code. So first of all, let's go through the cache, just because I can't remember what we did. Let's take a look at the, oh great, okay, there's nothing in here. Now the reason why there's nothing in here is because yesterday I don't want to implement the cache yet. We do need a cache at some point, you know, but it's a nice to have. It's a feature or an enhancement. It doesn't actually, you know, it's not critical to the core logic of what we're trying to do here. And the first piece is load in, you know, gigs and gigs and gigs and gigs of data into a terminal UI really quickly. And we can't do that if we're passing the whole thing. Obviously, we're going to need to seek through the file. And the cache is a way to speed that up if you're kind of scanning. We don't need it, it's not critical. So let's move on to the, what was I looking at now? Hang on a minute. What was I just looking at? Oh, the cache. Yeah, I was looking at the cache. I'll get myself all mixed up. Let's zoom in just a bit more here. All right, so we got some constants defined, which is good. I think we set those up yesterday. We have the index builder. Now the purpose of the index, and like all indexes, is going to do two passes. It's going to scan through the index and pick out all the metadata, so we know like paths, and we know I can't even remember what we were scanning in the metadata. We'll find that, but it's, you know, it's some high level metadata without the response body, which is where, you know, the bulk of the data is always going to be, is in that response body. So we are not going to be loading that up front because we only do that on demand when we want to render it out, or we're receiving a request to send the response back to the browser. So the way that the index works is, well, I'm assuming I haven't got this far from the code yet, but we're going to, or the design is anyway, that it scans through and it will then build that index. I think I called it what did I call it? Horrificate? We gave it a fun name. I can't remember. Anyway, like as a post process, as a first pass, you build the index, and that's what this code is here. It's reading all. That is a bit concerning. Read all. Read the entire content. What is that? Why are you reading all the content, Claude? Why are we reading all the content? That doesn't seem right. It's not right. Hey, I built it for you. Oh yeah, I'm reading all the content. Oh yeah, you're right. We've still got all the work to do. I mean, please don't be, please. All right, you know what? Let's do this. Let's bring back up Claude. This is where we were yesterday. This is where we left off. I'm gonna ask Claude what on earth is going on here. Hey Claude, in index.go. On line 54, we have full content equals, and we're using IO read all. Can you explain why we're doing that and tell me why we've done that and what the purpose is? I thought the purpose was to scan. What's going on here? Tell me our rationale and thinking behind this. Okay. Let's see what Claude comes up with. I'm just waiting. Just waiting. What are we doing here, Claude? You gotta help me out. IO read all. I can't remember what the API is or how that read all is operating. If it's going to give us a buffered reader, then that's different, but I'm not entirely sure. I'm hoping it says, let's see. Oh God, you stupid. I knew it. Good catch. This is actually a fundamental architectural mistake I introduced while fixing the byte offset tracking. Yeah, because that doesn't make any sense, does it? By doing IO read all on line 54 and storing it in file content, I'm loading the entire freaking har into memory. Oh, Claude, you're so stupid and you're so smart. It says, look here, your own analysis defeats the entire purpose for streaming. You know, this is where AI is so dangerous. It's so dangerous. What we've built is a lovely engine that kind of works but doesn't work at all. And you're fooled and lulled into this sense of security because the tests all pass and the benchmarks are strong. If you haven't read the code and you don't know what the code is saying and don't know what it's doing, it's like, as I said, it's like giving guns to children. So you are just inviting a horrific time, pun intended. Okay. So why did you do this, Claude? It says the wrong reasoning. So we were fixing bugs yesterday. And it says, when I fixed the byte offset tracking, I needed decoder input offset to get accurate byte positions, which is the right way to do it. File content available for the reader to use since I changed. So I thought, load it once, keep it in memory, then byte slice access is instant. This is wrong because it doesn't make any sense. It doesn't make any sense at all. Let me think of an interesting metaphor. Oh, and I can't really think of one off the top of my head. But you know, and I'm bad for using metaphors, to be honest. Bad. So Claude is telling me when they made a fix, file content. Why's my mouse gone dead? My mouse is not on. Why? It's not moving. I can't control it anymore. I'm about at the end of my wit with wireless mice. They are extraordinarily unreliable. They are extraordinarily poor at when you've got a large amount of equipment around. The interference, the wireless interference is off the chart, man. I am struggling with these mice at the moment. I thought my machine was all janky yesterday. It's not. It's the whatever software Logitech builds or whatever is, it's usually Logitech, to be honest. It just doesn't work. Like, it doesn't work under load, and I'm finding that my mouse is just janky and I can barely control it half the time. And then it comes back and it's all fine, and then it's like jank, jank, jank. I'm sorry, I'm just moaning here. I'm just thinking out loud. But it's why I slow down a little bit sometimes, because I can't get my mouse in the right position because there's something interfering. I don't know what it is. I've actually bought a wired one just because, you know, anyway, I'm not going to talk about it anymore because you don't care, do you? You don't care. You care about the code. Care about the code. All right. This is wrong because the original design intent of all this, the index buildings, we stream through the file once and we pull out the lightweight metadata. That is what it's for, right? Don't load it all, just stream through the parts and pull out the metadata, index it as quickly as we possibly can, and then we can just do O1 lookups, right? And what you've done is open the whole thing, read it all into memory and using it there. It's like, it's stupid. It's stupid. All right. Okay, so yes, we need to track byte offsets during streaming without keeping the file in memory. Okay, let's put Claude straight. Yes, Claude, you're absolutely right. This time, you're absolutely right. In the fact that you have deduced correctly that this is absolutely wrong. We should not be loading the whole file into memory. It defeats the entire purpose of this engine, the entire point. Because if we're going to do that, we might as well just use JSON and Marshall. This is pointless to load it into memory. It absolutely has to be done without loading into memory. So please undo this fix. I don't know why you went down this avenue. It's completely incorrect and completely against the design document. There we are. Let's go. Recombobulating. What are you recombobulating, Claude? You're absolutely right. You're absolutely right. Absolutely right. So, I apologize for that terrible detour. And now I can see. Let's actually bring back the code so we can see what's going on. And here's the code changing in real time. I don't know why it's changing all over the place. Changing all over the place. So times like these, I really enjoy these little things. They're called Nido. My wife found them. My kids like them. Well, they destroyed theirs and lost them within 10 seconds, but I kept my one. And I had a pink one, like it was like a little gummy, and this was a cube. I squeezed them. They're like the fidget spinner things, but you know, they're not rubbish. It's actually like the old stress balls. You know, those foamy stress balls. They were quite rubbish. Sometimes they're a bit gummy, but this, they've really got this amazing goo inside it, and it's very viscous, and it's very, very, very good for squeezing when you're waiting for Claude to mess up your code even more. When you're waiting for Claude to come along and go, "You're absolutely right. Do I want to proceed? Let's see what you have decided to put in here." Oh, it is a test. You're running a test. Yes, Claude, you should proceed. Next, verify memory usage is actually low. Yes, we should be doing that because otherwise, what are we doing? What are we doing? What are we doing, Claude? Running those benchmarks again. Those benchmarks were impressive, but they're only impressive. They're only impressive if you're not loading it all into memory and doing O1 lookups. That's I don't know. I don't trust anything you're doing now, Claude. I think you've gone off the rails. I am in the background. I'm going to load up codex. I'm going to load up codex and get started. Use codex web because man, this mouse is driving me crazy. It's driving me crazy. It's so bad. It's so bad. It's so bad. I need to get that wide mouse. I need it bad. All right, let's configure my repositories. You know what I'm going to do? While we're waiting for Claude, I'm just going to come over here and see. There it is, Chrome. All right, great. Still getting used to my buttons. PBBF. This mouse. Can't control it. There it is. Oh, that's annoying. $32. All right. Should be logged in. Okay. Got the codex connector. review request. Yes. All right. Select repositories. We want to let you into Braid. There you go. Braid. Now you can see Braid. I'm using the web one because I can't actually log in to Codex using my Cisco account on this machine. It won't let me. It's too secure now because we have all kinds of security agents and stuff that block all access for auth2 and SAML. So yeah, I can't. So I'm just going to use my own OpenAI account, but I'm going to use Codex as a code review. We're going to have it look at what Claude has done and see how well we get on. So now this mouse is bloody bleeding hell. It's terrible. Why are you saying you can only manage configure repositories? I've already done that. We've already done that. We already did that. There you go, look, it's right there. Select repositories, right there. Maybe I need to refresh. Oops. Can we see it now? There it is. Braid. All right. So now we've got a code review in there. I can bring it back to the terminal. We're gonna have to commit the code first before we can do a code review. Oh, look, my mouse has gone off again. Need to install some kind of backup or something because it's just going out constantly. It's not a good day for a wireless mouse. Not what I've got anyway. It's rubbish. Alright, I've got two mice up now. Got my backup on. Let's see how well that one is going to handle it. No, not even moving. That one isn't even moving. Nope. You know what? We're just going to have to push through. We're going to have to figure it out. Alright. Perfect. Here is now what we have. The correct implementation. The architecture has been fixed. Returned to the way it should have been. Streams through file only once using the offset. Thank you. Tracks every byte position for each entry. Thank you. No file content stored in memory. That's right. Temporary allocations during parsing. Yes. We want to keep the file handle open with a mutex protection. Good. We have the exact byte offset in the file. That's exactly what we want, exactly what we need. We read only that entry using IO limit reader. I've not seen IO limit reader before. Let's take a look at that. Oops. IO. Limit reader. I should really read the docs, but this came up first. Oh, it's got ads on it. Yuck. Let's go over here. Limited reader? It's limited reader. Limit reader? I don't see limit reader anywhere. IO limit reader. Where's limit reader? There's limited reader. Oh no, Claude, have you made another mistake? Oh. Hey Claude, did you actually run the code? I can't see limit reader. I can see limited reader. Which one did you say? Actually, no, I'm getting confused. What is it? What did you say? Limit reader. It's a limited reader. There's no limit reader interface. There is limited reader, but not limit reader. I guess quoted that. That's wrong. Should be limit reader. Limit. Let's see. Let's see. Let's see. Let's see what Claude says. Did you actually run the code, mate? You're right to question this. Let me verify. Code's running. So, oh no, there is a limit reader. I am wrong. If we go back to Chrome, no, I'm wrong. It is limit reader. I'm wrong. Limit reader returns a reader that reads from R but stops with the end of file after n bytes. Perfect. That's exactly what we need. Exactly. Okay. Maybe you are smart. Smarter than the average bear. Claude. Maybe you are. This is exactly what we want. Yeah, it's exactly what it said. Yeah, perfect. That is right. That is right. Okay. Well, let's go back through this code then, because the index is where it's coming from. So, bring up the code. Let's close that off so we can see a bit better. I'll zoom in. Yeah, this is all fine. Access hash. Super fast hashing library. Parse-har. Build. Parse-har. Hash reader. Well, it's parse-har that's going to be doing the most of the work. There's a new decoder. Tokens. Oh, this is... Let's look at this. JSON decoder. Yeah, that's right. That's right. Decoder. Decode. Yeah. Yeah. This is it. This is what we want. Key create. Okay. It's tokenizing it. And then it's decoding. Perfect. All right. So what is happening here is it's reading in. Let me just make sure it's reading in a line, or is it from A to B? Decoder. Decode token. Oh, it's just basically just reading the tokens here. Index version. Creator. Browser. Key entries, and that's it. That's all it's reading. This is it. Now it works. Now it looks like it's real code doing actual work for real, not pretend. Read it all into memory. Useless. All right, so I am going to split my screen again, and I'm going to talk to Claude just to keep the code up there, just for fun and games. Fun and games. Can you rerun the performance code reviewer and perform a code review yourself to validate that the code that we have actually adheres to our design document now, and rerun those benchmarks benchmark tests and validate that we are not consuming vast quantities of memory at all and everything is working to design. Thought for 2 seconds. And we're running our performance code reviewer agent because this is a very good 30% slop cut down. When you run this, it will catch a lot of sloppy slop, particularly if you configure it and tune it for your own use cases. I find it very useful. Very, very useful. Well, Claude is doing his thing for a minute here. And once we got that in there, we can ask Codex to suck it all down and do the same thing again and see what Codex says. Waiting. I want to use this opportunity to step away for 1 minute and have a quick bio break. I'll be right back. Do we want to proceed? What have you done here, Claude? Let's take a look. Oh, it's a memory test. Okay. Yes, I want you to proceed. Please do the memory test. That's exactly what we need you to do. Cannot run Go test files. Yes, I want to proceed. Lazy loading. Metadata only. Perfect. Yes. String in turning. Critical for memory use. 256 shards using x6 hash. That's good. Reduces a lock contention during concurrent builds. That means we're not locking and unlocking as much. And 6,866 entries with many repeated URLs properly deduplicated. That's just, oh, okay. So it's actually testing the string in turning is actually deduplicating. Good. Optional caching. Interface exists, but always use no op cache. Yes, the LIU. Last recently used. Yes. Lovely. Yes. Yes, it is acceptable with my earlier decision, Claude. Performance verification. So a design goal is sub-millisecond entry access, the random access, 0.25 milliseconds. Now that is what I'm talking about. That is 275 nanoseconds. Metadata access, 187 nanoseconds. Zero allocations in memory. Get out of town. Design goal, 0.1 random access. 5 megabyte. Come on, man. This can't be real. This is too good to be true. 5 megabyte file, 274 nanoseconds. 50 and 500. That can't be right because it's faster for 50. Consistent. Well, it's consistent regardless of the file size, and it truly is. It's how. I mean, it's the index. It's how long does it take to index? Reading 100 entries stays at 3 to 7 megabytes. 500 megabytes, 3 megabyte index after GC. The agent identity. Okay, well, yeah. Okay, so I've got my big red book of mistakes here, and I'm gonna make a note. Make a note about this. I want to verify that. What do I want to verify? I don't know yet, because I'm thinking through this again, and that's what I want to verify. Yeah, okay. I don't need to write it down. It's just, okay, it's just, actually no, I'm going to write it down because there's still more to read. I want to verify the indexing. Per file size. So, indexing is going to be the bottleneck here. How fast can we index? How fast can we run through that and pull out all that metadata per, 50 megabytes versus 500 megabytes? It's obviously going to take longer, but how much longer? I don't know. That's what I can't see here in these stats. So I'm going to come back to that in a minute, but let's keep going and see what else it's found that have problems. Must fix. The token parser interface is unused. It should be removed or integrated. Well, it needs to be integrated. The no op cache, when you enable cache true, still creates a no op. Should fix. The workable duplication, stream range, and still okay. We've got duplicate code. And skip leading reader edge case. It's buffer handling with small buffers. Buffer handling with okay, so there's a code quality. Horrificate methods are empty. Why are they empty? Why are they empty, Claude? Why are they empty? All right. Final benchmarks. Okay. Well, there's my answer, isn't it? Indexing speed. The indexing speed. Oh, it's already there. At the biggest is a 500 megabytes. We still need to do 5 gigabytes, but we can come back to that. 1.6 seconds. So does that scale linearly or not, or exponentially? Yikes. Don't know. String turning. Yeah, this is all good. All right. Okay. Known issues from review critical. Yes, Claude, fix those remaining issues. And before you do that, can you tell me why the horrificate code was all just stubs and why it's not being completed? And what do we need to do to wire that up? I thought that was already wired up. And yes, fix the other issues as well. Clean and tidy for our first iteration. Not token parser. I said horrificate. I have to type that because the LLM is not understanding what I'm saying. Not token parser. I mean, was it horrificate? Let's see what horrificate is supposed to do. Oh, it should still be in your context. But the horrificate is supposed to be the post-process build. It's like, oh. Yeah, it's our finalized replacement. Both implementations return null because they're empty stubs. Why they're empty? When we originally asked to rename finalized, this is true yesterday because I hated the word finalize. It's very Java-y. Not that Java is a problem at all. Java is excellent and it has its absolute place in the world, and it's still like by far one of the most widely deployed languages out there. I was doing Java for a decade. Got a very soft place in my heart for Java, but in my opinion, the very humble one at that, Go is the replacement for Java. It's basically a complete replacement for enterprise Java, except it's faster and it's simpler, and it's smaller and it's less hungry on memory, way less hungry. Prove me wrong if you disagree with me, but having done Java for a decade and done Go for a decade now, Go is by far, it's what Java should have been from the beginning, in my opinion, which is why I'm sticking with it. I love Go, love it. Anyway, I digress. I am reviewing this. What should we do now? So I was wondering what happened to my horrificate method, why they were stubbed. And essentially, our whole stream is already doing everything. We've recomposed it and refactored it, so now it does the building, the indexing, and creates all the reader. It's all in one versus having it stepped out, which is fine. So what should we do? Should we remove horrificate entirely? Because we don't need it anymore, because build and initialize are doing all the heavy lifting for us. And it simplifies the interfaces, which is what I want. Yes. Yeah, if there's ever an option to simplify, you say yes. Should we make it simpler? Yes. Yes. Sometimes you have to make it more complicated because you just need more control. You need more options. You see this a lot in applications that have endless customization. You're like, why? But because there's so many ways to get something done, and so many people have different workflows that you just need that complexity, that control, that ability to rewire. That's one of the things that makes Splunk so popular, is because it's basically a sea of buttons, knobs, and dials under the covers anyway. Okay. Yeah, let's remove it. If we're already doing an all-in-one with the build and initialize, then we don't need it. And an additional method that doesn't do anything, let's get rid of it. Okay, so now hopefully Claude is going to be going through and fixing all those things and getting it ready for our natural code review, which we're going to run through Codex. We'll bounce that backwards and forwards for a minute or two. And, well, it depends, really. Codex might go, yeah, it's great, I love it. It might say, this doesn't do anything. But it does do something now, because I've actually looked at the code and I can see what it's doing. So it's not going to say that, but it might, we've obviously missed something, or this model has put some cruft in somewhere that we've missed. But I'm actually feeling a good 85 to 90% on this code right now. After looking at it multiple times, tuning it, refining it, building those tests, validating the things that matter, I think we're in a good place. We're only in the 69% or something code coverage. Once we've done the code review, we'll have the agent build up that test coverage. And then we can also start another agent thinking about, maybe we'll just wait. I don't know. We'll see. We can have another agent start thinking about the console element that's going to allow us to execute this part first. So what I'd like to do is we'll start with building a simple Codebus CLI that is going to just start the viewer, and it's going to read in the half file, or not read in the half file, but index the half file, and then bring up a hello world. We'll get hello world, and we're going to use bubble T as well. Amazing charm library that is just the best. We'll do that after we've finished our code review, just so you know what's coming up in the next couple of hours. Fixing the skip leading reader. I still actually made a note of this yesterday. We're using some of the older wait group syntax in some of our channel operations, and that's fine. But there is a new syntax in Go 1.25, I believe, that allows us, it actually mimics the conc library. Actually, while we're waiting for Claude, let's just hop over to Chrome and take a look at conc. Conc source graph. There it is. Better structured concurrency for Go. I've used this and it's really good. It's really good. And it gives you all these lovely little tools here. Like it's basically an improvement over the standard library. And yeah, how it handles a lot of the panic bubbling and context and all kinds of stuff that you error handling is particularly good. And really why it exists is to remove. Okay, well, when you're doing a lot of stuff with lots of channels and a lot of concurrent programming and async programming, even though you think it's clean and it's tidy, but it's not. There's all kinds of Go routines leaking or not finishing or not completing, because everything is executing on a scale that is incomprehensible to our brains. It's like, all right, yeah, that would go 1, 2, 3, it stopped. It's like, no. It could be 1, 3, 2 never stops, 2 never started, or 3 would just hang there forever, or 1 will hang there forever, and it says done, but it's not. In long-running systems, that's a massive problem. In a one-and-done system, who cares? It's a compiler. It's like, it's finished. The job is finished. The application has stopped. But when you're building platforms, hang on a minute. Let's go back to do a split so we can see what Claude is doing. It's just frozen on me there, saying I want to do a final mem check. Yes, I do want to do a final mem check. Go, Claude, go. My mouse is absolutely fine now. Like, it's rolling as smooth as butter. I don't even know, man. I don't even know what it is. Nothing has changed. Again, not that you care. Not that you care. Why would you care? But anyway, I do want to change. Anyway, I was talking about Conk, wasn't I? And why it's great. It's a great tool. But what happened is in Go 1.25, is they actually implemented the same syntax. The syntax behind the wait group is that you would just call like a Go function on, like, you create a wait group instance. Maybe we can get the code back up. Get the code back up. One second. Sorry, my door has just opened. It was my beautiful wife delivering me McDonald's. I don't think I can eat it on the camera though, so I might have to take a little break in a bit and go and eat that before it gets too cold. But she bring me a coffee, and I'm running low because my mug is running out. And God, I love my wife. I'm just gonna text her and say, "Thank you, darling. What a sweetheart." Thank you, my beautiful wife. So sweet. I'm just gonna go grab that coffee. I'll be right back. It's on the floor over there. Okay, back. Yeah, so with the wait group, you would create a new wait group, and then you use this go, and you pass in a function, and then you just call wait. And essentially all the wait group handling for adding deltas and marking things is done. So the count goes up and down in the wait group. It's all handled for you. It's like, oh, that's so nice. Thank you. What a great interface. Problem, well, no, there's no problem. Let me say, it's no problem. No problem. Not a problem. Great library. Nothing. No problem with this whatsoever. I use it. I love it. The kink is that Go was very inspired Go team, and they brought this in. They brought this design for weight groups into the standard library. I haven't used it yet, so actually I haven't done a deep dive on whether or not the standard library implementation is as good as this conch implementation again, which I love, which is great. No problem there. Hang on, do I have a Chrome and a code? No, I don't. I don't actually. So I was going to split the. Oh, maybe I do. I've got the wrong terminal. So what I'm trying to do is show this, but I've got the wrong terminal up here. I've got a different terminal, but that's for later. Anyway, I'll go back to Chrome. Yeah. Anyway, Go's implemented this already, and I want to see. We can actually do this a little later. Maybe we'll do it after the code review and just say we'll swap it out, or maybe not. Do I care? Do you care? Does anyone care? I don't know. Make a decision. quobix, make a decision. Yes. Yes, I do care. I do care. Because I want that functionality, but I don't want to take the dependency. But I want to see if we're giving up anything. So I'm going to do that. Oh no, it's slightly cold. I have to go and warm that up in a minute. I'll warm that up in 1 minute or two when we get the next thing going here. Actually, when we get Codex running the code review, I'm gonna go and warm up my not hot, but very generously fetched coffee. All right. Let's see the final verification. All issues resolved. Here's the complete summary. Everything fixed. Verificate. The index builder, token parser, dead code, extracted the workable pattern. We've got fixed skip leading reader, the edge cases for small buffers. Yes. Yes. Memory efficient. So okay, the final verification, a half a gig file. Index memory after garbage collection is 3.3 megabytes. That's 0.66% of the file size. Very good. Temporary during build. See, this is my concern. This is my concern, is that we're fooling ourselves. We're fooling ourselves by saying, oh, look, the memory that's left is only 3.3 megabytes, but we need to use a load of it to index it. Now, is that just Go being greedy, or is that we're actually using that? And does that then scale linearly? That's what we're going to need to test. You know what? Before we even go to code review, I'm gonna have it look at that, because that is bothering me. This is what's bothering me. It's the memory use of indexing and the speed of indexing at scale. Half a gig, sure, but you take that to 20 gig. What are we looking at? I'm not sure. You know, in this machine here I've got quite a lot of RAM. I've got 128 gig, but not everyone's gonna have that on their machine. 20 gig is a huge amount of memory for reading a text file, and we shouldn't be doing that. So what I'm going to ask Claude to do next is create some more benchmarks, but we need to increase that file size to at least have another variation of 5 gig, and then we need to validate that we are not using 5 gig of memory to pass the index, because we're right back to square one and we haven't solved anything. And it's another viewer selling bot that has sent a message through Twitch. Thank you, bot. But no thank you. We don't buy viewers here. All right. Okay, Claude. I'm concerned. I am concerned that we are just going to use all the memory. So let's bring that back. I shouldn't have said so. Memory. When we're indexing, you said that we're using up to 500. Hang on, let's see what it was exactly. What was it exactly? 559. We're using 559 megabytes of memory that gets garbage collected. Okay, it gets collected, but we're using it. That's my concern here, is that is going to scale linearly, which means that you're going to have to need at least, the file size in available memory, which is against the design pattern. I need to verify that when we're indexing, we are being super efficient with how we are indexing, and we are using a very small reusable memory block for scanning in those log files, and we're not blowing up whatever storage we're using for that temporary data to use all the available memory. That is the wrong design. Please verify that we've done that correctly and let me know what your finding is. Do not change anything, just do a verification. Wow. Ghosty is telling me that pasting this text... hang on, I've got the wrong... Should be my terminal back up here. Got a pop-up saying this contains... This text here contains a command, a malicious command. I don't know what you're talking about, like Ghosty. I don't think you're right. I think you're wrong. There's no command in here. Anyway, so just to verify, look, it's saying that temporary during build is 559 megabytes of garbage collected, and that's the problem. I think that's a massive problem. It's not right. It doesn't feel right. Yes, I want to proceed. I need you to create a 5 gigabyte file to verify that this is not going to scale linearly or exponentially. Okay, while it's doing some memory tests, I'm going to go and warm up. It's building a 5 gigabyte half file now. I'm going to go and warm up my coffee. I'll be back in just a minute. I put my coffee in the microwave and I ruined it. It's in the McDonald's cup. Does not do well in the microwave. Don't try it. I pulled it out and I was like, ugh, this tastes like burnt plastic. And then I looked at the side, it says, do not microwave. Stupid boy. Stupid boy. I should have microwaved my food. Oh, I'm not very hungry, to be honest. Not very hungry. All right. Let's see. The smoking gun. Oh, God dang it. Exactly what you're absolutely correct. Oh, again. Look at that. Critical design violation confirmed. The problem, as I suspected, this decodes the entire entry. I thought that was going to bring back a streaming reader, and I was wrong. Should have looked at the API. Should have done it right then. I knew it didn't feel right. Smoking gun. We allocate 5.4 gigabytes temporarily to build a 29 megabyte index for a 5 gigabyte file. 29 megabytes of memory for use for a 5 gig, that's fine. But allocating the 5.4, that's the main problem here. That's the design flaw, and that's not. That's wrong. It's wrong. We can't allocate that much memory. Look at the size. Look at that. Peak heap. The garbage collector is actually doing a really good job of keeping that memory low. But the allocations is the problem. We're asking for huge amounts of memory. And the GC is like going... Yeah, the decoder.decode entry loads the full haha entry struct. Yes, that includes the entry response. Yes, that's where the nightmare is coming from. That's not what I thought it was doing. Design goals, streams. Yes, the design violation. This is the key. We want to stream through the file, extracting only the metadata to put into an index. And we are decoding the full entry, includes the response body, which is the problem. And yeah, we would need 50 gig of a 50 gigabyte file. This is the wrong design. All right, so the fix required. Okay, so we just need to change the scan type. So instead of decoding the entire thing, we just use the metadata off the decoder. All right, the entry metadata. Yes. Okay, it's a pretty simple fix. We just avoid decoding that one field. All right. Yes, Claude. It fixed the design now. Oh, sorry. Not fix the design. The design's fine. The design is fine, mate. Yes, Claude. We need to fix this. We should not be loading the response body in when we're doing that indexing. It defeats the purpose again. So decode only the fields that we need for the index. Do not decode the response body, and we should not be allocating, like for like. We wouldn't. I would like to see that memory use stay under 100 megabytes. I'll just leave it there. Let's see what it says. I'll switch over to water, I guess. Oh, that's interesting. This is a green can. Looks like it's an invisible can. So I'm just setting up a couple of things over in Slack while, excuse me, while we're waiting for Claude. I got Slack, I got Discord, I got a feed coming in from Twitch and YouTube. I'm not sure if anyone's even watching. If you are, thank you. Thank you for watching. Really appreciate it. Say hello. If you're not, then why? Looks like Claude is updating the index. Doing our proper decoding now. Proper decoding the way it should be. I'm not sure you can hear that. It's my stomach growling, and that is because there's a McDonald's sitting next to me, and he knows it. So do my arteries and my heart. All right, we're running the test. Yeah, let's try that 5 gigabyte memory. At 5 gig memory, let's see how it goes. Look at the heat, look at the heat, heap. 13 meg, ooh, 19 meg, 26 meg, 19 meg, 30 meg, 30 meg, 20 meg, 29 meg, 34 meg, 35 meg. Oh, it's dangerous. Creep in. No. We kept it under 50 meg. Now that's impressive. That's impressive. Really impressive. Yeah, let's run this test. Come on, off you go. Conclusion, decoder does allocate the full string. Whoops, there goes my stomach again. Hope you can't hear that. It's very loud. Yeah. critical memory file ratio during build. Total allocated during build 60 gig. Look at that. Really gonna have to dial down on all of this. It isn't working. Explain memory. Understanding the memory metrics. David Serrano. Hello, David. Thank you for watching. You're up early. 9:36 a.m. Ooh, not too early. What, 6:30? Probably having your breakfast. Your fresh mangoes and granola or whatever it is that you have for breakfast. Something healthy. Flan, maybe. The question is, I would love advice. What's the best thing you can do while waiting for Claude to run? My mind easily wanders and I get distracted. You know, that is a very, very good question. We were just talking about it yesterday. And normally what I do is I run two agents, an A and a B agent. Let me just let this run here a second. I run an A and a B, and right now we're running A. I've got B queued up, it's just not doing anything. Damn, I'm up. I'm always up this early. I'm actually at the gym. Oh, okay. Well, pump some iron, lift, go harder, do another set, or something inspiring. Back to the question. What do I do? So I run an A and a B. The B agent is actually sitting idle right now because I need to focus on this, because this is the most important part that I can't let my mind wander on. I can't take my eye off the ball right now. This is the design phase. If this is wrong, if our core engine is wrong, the whole point of this is that we're actually using sorry, I'm distracted by what Claude is saying here. I'll get back to your question and I'll read this. I run to the other agent and I start work over there, and I change the context. So if I'm running back-end tasks, I'll come up, flip over and start looking at front-end stuff because it's a complete context switch, so it completely distracts me and I have to start thinking again. And normally I'll get stuck in, or I'll start looking into something and then immediately have to jump back to the other agent because it's got a question, or it's stopped, or it's finished. So depending on how long it's running, if it's a really deep complex issue, I will flip over to the other agent and then just start building in a different context. Usually front end, back end, but it could be two back ends or two different parts of the system, or working a library, then working in one of the applications that consumes it, or working in another application that sets it appear. A flip to different context stops the mind wandering, and it keeps you focused and keeps you operating at your operating temperature, keeps your RPMs up high. I'm not sure if you can drive or not, I can't remember, but when you're doing performance driving, RPMs are everything, and keeping those RPMs high is essential for power, and this keeps those RPMs ticking high. Back to our analysis, Claude. Okay, for a 5 gigabyte file of index building, the peak heap was 47 megabytes. I'm okay with the heap being that size, but the index after GC is 29. Great. Total allocated was 60 gig. It was recycled though. GC cycles. Yeah, I don't know. Am I okay with this? The heap never gets above 47 megabytes, which is fine. That's actually how much the application is consuming. It's the playground. But the allocations is how much memory is being requested, and then being recycled by the garbage collection, which 682. It's going at it. So the root cause, we can do better on this. Even with selective parsing and using JSON raw message and Go's JSON decoder has a fundamental limitation. Decoder still allocates the string in memory. Okay, this is part of the problem. So the decoder must allocate string values before we can skip them. For 70,000 entries, which is 70k bodies, it's immediate, yeah, it's allocated, but then immediately garbage collected. The heap stays at 47 megs, which is fine, which is good, but the GC is keeping it there because it's running 600 times. So the question is, right, and it's a legitimate question. It's a legitimate question from Claude now. What do you care about the most? What do you care about the most? I care the most about how much memory we're using. And we're using under 100 megabytes for the entire indexing process, which is great. 47 megabytes is what the heap never got above 47 megs. I watched it as we ran the test, which is good. It's allocating. It's asking for all that memory because we're running because of the decoder, the JSON raw message and JSON decoder. It's limited because it allocates the string, and that string is being allocated, but then it's being gobbled back up and reused immediately. So the only real concern here is what is the cost of the Stop the World GC collection, and is it really gonna, because it's a one-time thing, it runs once. Do we really care? Because we don't need, we don't need 6 gigs. It's accurate here, so we don't actually need 6 gigs of available RAM. We only need 47 megabytes of RAM. But we are actually asking for 6 gigs of RAM during the indexing process. It's that, do I care enough about that? Do I care about that? Do I want to refine that even more, make it even more performant? I would say no. I think there's a possibility, and when we use Sonic, I think this goes away anyway, because part of the process here is get this working as is, and we can upgrade to Sonic, which is a much faster JSON parser. We could have effectively get rid of all of this stuff, because this is all done through interfaces anyway. We should be good. So this is my answer. I think we're good on here, and I just want to verify with Claude, and then we can move over to code review. No, I think this is fine. It's peak heap, which is what I care about. That's actually how much we're running against, which is 47 megabytes. That's good. That's actually a really good target for working with 5 gig files and not asking for not using more than 47 megabytes. Do I care that we're making over 600 GC iterations during the process? Not really. It does seem high, but it's something I can live with for right now. The next question I have for you, Claude, is I want to ensure that we're going to be able to replace this with Sonic, which is something we discussed and looked at right at the beginning of the design phase, because it's a much more performant JSON parsing library than the standard library that ideally doesn't have these problems. I want to make sure that Sonic is something we are still going to be able to just drop it in with I'm getting myself all muddled here. Drop it into the library because we've composed everything with interfaces. Let me verify our current architecture and what would be needed for Sonic. Well, it should be able to just go straight in. Don't want to use Sonic, actually, just make sure. Do not implement Sonic yet. I'm just asking a question, Claude. I'm just asking a question. Don't build anything, just verify. Why are you doing a web search for Sonic JSON library Go by Dance GitHub API decoder token? Why would you do that? Chaz says, I got the one-time paid version of Mac Whisper for voice diction. I really like it. What do you use? I use this. I'll show you. I use a tool called monologue.2. What is it? Where is it? Oh, not monologue.top. There it is. Monologue. I use this. I think it's built on top of Whisper, but it's just got this really nice interface inside OS 10, sorry, whatever. And this little widget comes out and it gets all these sound effects, and you've got this really nice console, and it works really well, and it actually does a lot of screen reading for you as well. So it looks at your terminal or wherever your mouse is focused, it's reading the screen, so it has context, so it puts names and parameters in accurately because it knows you're looking at code, or you're writing an email, or you're in a terminal, or whatever it might be. Anyway, yeah, I use this. That's what's actually running in the background when I'm doing my talking. Until I find something better, this is good for me. I've already paid for it anyway. It's like $100 for a year or something. And it works great. It's way better than the built-in diction from OS 10. That's terrible. That barely works. This is really good. Let's go back to our terminal, because I've got a question here from Claude, and he's saying, we're using our abstraction. No interface layer. Remove the token parser. Yeah, the problem. I removed the token parser as dead code. God, I knew it. It wasn't dead code. We designed that, and without it, we're now tightly coupled. Yes. Okay. All right. Option 1. No. The correct solution is to re-add the coder interfaces that we removed. That wasn't dead code. It was to allow us to be able to swap out the standard library implementation for the Sonic implementation down the road. I need that. It's a critical part of the design document. If you go back and read it, we have gone down the wrong path here, Claude. Please add back what you removed and make sure that it works with Sonic, and that we can do that in the future. Not right now, but in the future. I'm actually going to need to take a break in a minute and eat some food. Going to need to eat. We've been going for an hour and 42 minutes. It'll take 5 minutes to eat. Once we've actually gotten past this part. Because the code that we have is good. It works. The GC pressure is still a little high for my liking, but it will work for our first version as an engine as we then build out. Then I want to be able to come in at the end and bring in Sonic and remove all of that GC pressure and really supercharge that part there. So with the basics, we're not using very much memory, but it's not particularly great because of the limitations of the standard library. I don't know if the new experimental library has improved it or not. My friend Roger would know. He's been playing around with that. And right now we're just waiting for it to do the right thing and put back right at the beginning of the session. We deleted some code. Oh, it's dead code. I was like, is it dead code? No, it's not dead code, is it? No, it has a purpose. It's interfaces. There's an interface between having the standard library hardwired into the code versus having it extracted or exposed in an abstract way through the interface, so we can swap out Sonic for the standard library. If we can't do that, then the design is pointless. But if we do it correctly, it means hot swap. That's what we want. Hot swap the engine. Alright, now we're building some tests. Let's see. Yes, I want to proceed, and I don't want to have to ask you to run. Go commands, just go for it. Go for it, Claude. Actually, I'm going to do that now. I'm going to jump off for 5 minutes. I need something to eat. My stomach is giving me grief. Just before I do that, David Serrano says, I met a sub-agent called the Jaded Architect, and I prompt him, you're a jaded architect with over 30 years of experience cutting out BS from enterprise software. The sub-agent is incredible. He keeps everything super concise and does not add extra BS features I don't need. He doesn't implement dry though. Well, add that to your... I hope I'm not your inspiration for that. I hope that's not me. And I hope that's some other... I'm not jaded. Do I look jaded? Maybe I'm just assuming it's me. I'm hoping it's not me. I'm hoping this is just something fun. Anyway, I'm just mucking about with you. Don't worry. Yeah, add dry. Add dry. Stay dry. No wet slop. All right. I think this almost be done in a second. Maybe. Actually, no. I'm gonna let it go again because I do need to eat. All right. I'll be back in a bit. 5 minutes. 5 minutes. All right, I'm back. Sorry it took a little longer than I expected. Things happen in life, but we're back. We're back live in Beef HQ. Let's see what we got. It says, I've restored the decoder abstraction properly. Everything's now in place, which is the way it should be. Architecture for sonic swapping. Yep, that's what we need. Standard lib decoder implementation. Yep. To swap to sonic in the future. If sonic lacks these methods, all right. I don't want you to do anything right now except to validate that the sonic library actually has the methods that we are expecting and it's going to conform to this interface. Just make sure. And while it's doing that, let's go take a look at some of this new code. Some of this new code. So we change the index. Take a look at that. Build, hashing reader, pass har. All right, let's take a look at the har parser. Har decoder, token, all the same thing. Same thing. Nice interface. Pass log, token. Still with the same limitation as before, but we're not. Pass entries token. Yeah. It's the same. It hasn't changed anything. It's implemented it correctly. This is the correct code. It's passing the entry metadata using the token. Why are these back? These are back. You shouldn't be in there. Hang on. Claude, what are you doing? Claude, can you not search the web? What are you doing? Let's get the right URL. Let me do that. I'll do it for you. What are you doing, you nutcase? Let's go find it. It's what is it? ByteDance/Sonic. Well, I'll spell it right. Quobix. There it is. All right. Claude, I need you to check the code out. Like, check it out. Check out the repo locally or in temp or wherever the hell you want. I don't care. And look at the code. Don't keep doing web searches. That's no good. I thought I pasted that in. There you go. There we go. All right, off you go, Claude. Off you go, mate. Go figure it out. In the meantime, while you're off, yes, back in temp. This started date, time. These cases in the index. I thought that they were all solved up. Oh no, these are different ones. Okay. All right. Well. We're gonna need to fix those. Oh, there they are. These are the ones we fixed. And I guess I didn't look down at these ones. Did the same thing. Pass entry metadata. This is new code. That's why. He's modified it. he. I say he. Claude is not a he. Claude is a it. I've been looking at index.go and I've noticed that there is more string literals in the parse entry metadata method that you've built. Can you add those to the constants at the top of the file, please? I'll wait to fire that off. I'll let the current task finish before I start getting on him about that. But we'll move on. There's quite a lot of them in there. Yeah, it's quite a lot. Okay. Oh, we got more. And in the parse request method, please. Let me edit that. Mm-hmm. And this one. I think it's a private method. Parse request is also private as well. Okay. All right. Oh, I'm waiting for Claude to go and read all of that code in Sonic, just to make sure that we're adhering to the right interface, and that we've exposed our interfaces correctly. Okay. Great. Okay. Critical finding. Sonic cannot replace our current implementation. Based on examining the actual Sonic source code, here's what I found. Decode more. This is a primary design missing from Sonic token. Oh. Sonic uses decode, which it does the entire struct, which is what we want to avoid. Exactly. Exactly right. We want to avoid that. Maybe Sonic won't help us at all. Or maybe it will. Okay. I'm not going to rabbit hole on Sonic, to be honest, because I'm actually quite happy with the performance we already have with the standard library, to be honest. By using no more than 47 megs on the heap, that's impressive. For like a 5 gigabyte file, yeah, it's good. That's good. In my opinion, anyway. So, do we need Sonic? I don't think we do. Especially if it's going to be loading, decoding entire structs, that's the problem. That's the reason why it takes up so much memory, regardless. All right, I like your recommendation, Claude. I've thought it through. Let's do that. We're going to keep with the standard library. It does work perfectly so far. Let's see. We will see. In our sandbox, it works. It works to design. Does it work with the rest of the tools? We will figure that out. Tests only take you so far. And we're going to go with option 1. We're going to keep what we have. I'm pretty happy with the performance and the memory use, to be honest. It's good enough. It's more than good enough. It's good. Okay, so let's have Claude clean up these cases and these switch statements and use those as constants. Clean it up. I'm seeing a buzz. Things are buzzing on my desk, buzzing on my laptop. What's going on? What's going on? Nothing. Nothing's going on. Except we're fixing switch statements. Is there any more? Is there any more? Oh, there's even more. Can you just go through all of them, the private parsing methods, and determine whether or not you've done the same thing? Oh, look, you've already done it. He's already done it. He's already done it. It did it right in front of my eyes as we were. Thank you, Claude. Well, we're just waiting for Claude again. And at this point, again, waiting for him to do his thing, you get distracted. This is where I would normally flip over to the other agent and start working on the other piece. We haven't got the other piece yet. So it's a case of just sitting here and squeezing this down to the point where we're happy with it enough to, I want to throw it over to Codex. I've been talking about that for an hour now. We haven't quite got there, but you know, it's just what it's all about when you're working with AIs. You're handing over that fine-grained control for a much more granular set of dials and knobs at the high level, and you know, turning them is much less accurate, and you're hoping that the dials all fine-tune underneath, and you really got to get those big knobs, you know, in the places they need to be to make this work. But yeah, almost there. We're almost there. We're almost there. I'm gonna send this link to my wife so she can jump on the stream and laugh at me. She's downstairs watching television, looking after our son. No, he's at school today. He was sick. He's been off sick for a few days. She was looking after him yesterday. But oh, okay. Constants added. Sonic has the bits we need. Doesn't have token passing. Sure, whatever. But I'm happy with this. This is what I'm talking about right here. That is what's important. And we've replaced all these cases with constants. This is all looking good. This looks good. What the hell's this? Do we care about the... What is that? Why are you not handling the error? Just return the error if you can't write. I'm being too specific here. Let's jump back a bit and say it's good enough. It's fine. It's fine. It is fine. I'm gonna get that link though for my I want to get on my YouTube channel. Where is it? Live. Let me get rid of that. Okay. Let me send her a message. Send her a message. Say, hey, come and look at me. Look at me on the internet. Making a fool of myself. Hopefully she'll jump on. I don't know if she will or not, but there you go. Probably won't. Anyway, let's go back to where we are with Claude. And this looks fine. This index looks fine. Let's take a look at the interfaces, decoders. This makes more sense. Back to where it was. Yeah. Yep. Clean. Nice and clean. Nice and clean. And let's take a look at JSON helpers. Let's just bring up the code so it's full screen. Yep. Take a look at the streamer. It's looking good to me. This is all looking good. Yes. This stuff always trips me up. I always get these wrong myself and have to figure them out with profiling and debugging. No, not profiling, just debugging. The debugger is your friend in this use case. Streaming the indices. The stream result. Yeah, it's this code. It's this code here. Instead of using the weight group, this, yes, let's just see if we can use the new syntax. All right. Okay, Claude, this is looking good so far. Something that I do want to change though is in like the stream indices private method in default har streamer, we're using weight group, which is fine. It's totally fine, but we're using the old Go syntax, and in Go 1.25 they added new syntax for a weight group. That means we don't need to use the add method or the done method. Can you go and look at the documentation and the source, or just look at the docs? Just read the docs. Read the Go docs for 1.25 and take a look at the new Go weight group syntax and see if we can use it and modify what we have here. Just make sure we're doing weight group, weight group. Weight group. Where is it? Another one here. Weight group. And let's get that name right. What is it? It's default har streamer. And we're using the stream indices with a capital I. Off you go, Claude. Go do your thing. So Go 1.25 weight groups, new syntax. Back into the web search again. When I said read the docs, just read the docs. Did one search. Add done method. That's why would you pick? How did you get that from the prompt? Perfect. Go 1.25 added weight group dot go. Yeah, it's the same conc syntax I was talking about earlier. So let's update the code. Yes, let's update the code. Look at that. Delete, delete, delete. Delete, delete, delete. I realized I don't have my terminal on. So you can see the terminal. I deleted it. Great. Should work exactly the same. But we've deleted 3 lines. No, we deleted one line of code. Hooray! That's great. And then we'll probably add 4,000 more. Ruin it all. Ruin it all. 10:30 in the morning here. We're well into this now. We are nearly 2.5 hours in. The goal for today is, oh, hang on a minute. Claude is telling me he's done. Perfect. We're updated to Go 1.25, the new weight group syntax. And as I was saying, we don't need that add and done anymore. We don't need to worry about that delta. We can just let Go do it for you using that new syntax, and then builds it all out for you internally. It's using that conc syntax. I don't know that it has all the same functionality that conc has. I think conc has, got a load of great stuff in there, particularly with the panic handling and things like that. But maybe not. This is good for me. What else we got? All the tests are passing 71%. That's almost fine. Safer, cleaner code. The performance unchanged. The streaming tests work correctly. All right. Okay. Well, I'm happy with that, and I'm happy with this new syntax in here. This all looks good. I think I'm happy with this. Let's commit the code. Let's bring up my tool I use for doing that. Got tower. Bring up tower. See a whole bunch of stuff in here. I want to update the README because no, I don't want to update the README. Just delete a file. Delete a line. Actually, fine. That's whatever. I was trying to, for some reason, start Xcode. Don't you love that? Don't you love it when Xcode pops up because you wanted to click on a markdown file on a Mac? Don't you just love that? Now I got looking through. I'll make this a bit bigger so we can see the diff a lot easier. So the tool I'm using here is called Tower. By the way, if you've never seen it, I've used Tower for years. I absolutely love the visual Git manipulation. The Git CLI is fine, but it's so command heavy, and there's so many switches and knobs and dials on it. I just can't be bothered. So I really much prefer this as a standalone experience. I know JetBrains has a really good implementation. But I just prefer this, and in fact I also use another third-party diffing tool for when I want to do actual diffing. It's called Kaleidoscope. It's this actually. I'll just bring it up quickly while I'm just chatting here, just so you know what it is. We go over to Chrome and we do Kaleidoscope. There he is. Kaleidoscope. No, not the actual Kaleidoscope. Diff. There it is. Diff tool. This is it. I use this. I'm not running it right now because I don't need to, because I'm not doing any diffing. But when I do diffing, this is the tool that I use. It's got this 3-way merge feature in there, which is it's just wonderful. This is the pinnacle of pro user diffing on a Mac, in my opinion. Everything else adds diffing in as a feature. This tool It only cares about diffing. And all it worries about is diffing. It's not just diffing files, it's diffing everything. It's diffing, it's doing image comparison, file format comparison. It's truly is designed for doing a left and right and looking at it. I've taken a lot of inspiration from this tool, from my own tools. I love this tool and I gladly pay for it because they just do one thing and they do it really, really well. So yeah, I would highly recommend Kaleidoscope for diffing. I use it with Tower. And I use them as like a, as a combination experience between the two of them really. And I usually avoid all the IDE internal tools for diffing and for Git. I've tried them all. I've tried it in VS Code. I've tried it in JetBrains. Obviously the CLI. Then there's like Lazy Git. And I've tried all of it. This is the best for me. And there's also, originally, I started out well over a decade now, with a product called SourceTree from Atlassian. SourceTree Atlassian. I haven't looked at this. In, I don't know, 15 years. Oh, look, it's rubbish. Comparison. So this is where I started, was with SourceTree. And it was a great tool, but it was just a bit janky. It wasn't loved, and the diffing was rubbish. Excuse me, but it was rubbish. It's just. This is what happens when. Hang on. Bring this up. Jumped over to Chrome. Here it is. Look, here's SourceTree, and it's just like, nah. It's just look, nah. It's just not loved. Whereas Tower is loved. It's loved because they use it. This feels like it's a thing that got stuck in the side of a company somewhere and it's just maintained. Let's keep the lights on this, and they keep it going, but they're not loving it. They're not like, let's really dig in and make this a really good source management tool. And I kind of dived out of this over a decade ago because it looked like this, and it hasn't changed. They really haven't done very much with it. They haven't upgraded this. They might have brought it into the Atlassian ecosystem a lot more, but as an independent tool, it's non-comparable to Tower, in my opinion, my very humble opinion. And it is just my opinion, not a fact. Yeah, sorry. Nah, SourceTree. You were once my choice, but I moved on. To a new woman. Her name is Tower. She's much prettier, much fitter, and like great first-class support for all just. I love this tool. It keeps getting upgraded. They keep adding to it, and the workflow keeps getting smoother and simpler and more powerful. And it's got great GitLab and GitHub integration. Anyway, I'm a huge fan. If you're looking for something visual for Git and you want a quality tool, it's a Windows and a Mac, so either. Can't recommend Tower enough. Anyway, we've already reviewed this code, so we don't need to do too much work here. We've already looked through this, and you can see that the built-in diffing it's okay. But when I actually do a real diff, like between like a merge commit or a merge conflict, I'll actually use Kaleidoscope. It's just easier. Okay, this all looks good. I mean, we've already reviewed it, so let's just commit all of this. Okay, second review on the Horrificate engine. The memory use is under control. The design is right. We're adhering to interfaces, and it looks like we won't need Sonic after all, just using the standard library. Okay, I don't want to add this, and I don't want to add that. They should not be in there, and that looks good. Right, let's... Ooh! Risky here. Claude. We need to run some tests first, just to make sure. Just run tests. Did you run all the tests to make sure they're still operational? Before I press that commit button. Run, pass. Plus 90 lines. Let's see what was going on there. Run, pass. Run, pass. Looks like it's working. Yes, all the tests are passing. 32 tests, all passing with a 71% coverage. That's fine. Let's go. Let's go back to tower. Hang on a minute, click the wrong button. Oh dear. I clicked the right button. I need to get a button for tower. I've only got one left on my stream deck, and I need that to figure something out. I need to change it. I need to reconfigure it. Anyway, we're good here. Let's commit this code. Commit, and now we're going to push it up to main. Push straight to main. Go. I mean, why not? There's nothing in here, so who cares? Who cares? It doesn't mean anything. Okay, so our second commit there. We deleted some stuff. We rebuilt some stuff. In there, that's just our Go work file and our migration file. Keep that for now. We'll keep that for now. Just so we've got some history behind it and why we don't care. Just for now. And actually, we'll probably put that into the claw.md once we're actually moving and shaking here. All right, so that means we can actually get we can go and get Codex to do a review for us now. And we don't want source tree and Kaleidoscope. It's great. Don't need monologue or conch, all that, all this. All that. Oh no, I didn't need that. Stupid. Man, that was stupid. All right, let's pick braid. Okay, what should we code next? What's this? 1 version, 2 versions, 3 versions. We'll just keep it at 1 for now. All right. We're working on this new code base, and we've made a few commits, and we've built the first piece of the engine, the first piece of the motor. Sorry, it's not an engine, it's a motor. Let me actually undo that. First piece of the motor. And the motor is actually the name of the module that contains all the code. Can you do a full code review of everything you see in there, and both give me an analysis of what you think the engine does and how it operates, and the code quality, and any kind of obvious or glaring issues that we've missed, any design problems, any architectural issues, any memory leakage, any poor design hygiene. All right, go Codex. Let's go into the environment. Where's the environment? Edit environment. Oh, no, I don't want that. I haven't used the web. Well, I used it once, I think. Working on our task. Let's see what's going on here. Starting the container. It's going to pull down the code, most likely. Oh, I don't know. Let's find out. I've used Codex locally. I've used it in VS Code. Unfortunately, as I said earlier, I can't log in to my corporate Codex account on this machine. So I'm using my own here. And I haven't got like the CLI set up. That's what I'll do tomorrow. That's the change I'll make for tomorrow, is I'll get like the CLI environment set up and we can flip between the two environments. But for right now, it's just taking a look through the code. There it is. It's reading the code. Let me zoom in here so we can see a bit better. Here. It's reading the code. I'm just waiting for it to do its thing here. It's reading, thinking. Well, I don't know what it's doing. I don't know exactly what it's doing, but it's doing something. What are you doing? Running a command. What command are you running? NL. What's NL? Number of lines. Ah. I've just used like clock or something before when I'm doing code like that. Okay, here we go. We work for 2 minutes and 38 seconds, and this is what another agent thinks. The motor package builds a lightweight index over HAR files, and it captures metadata like the offsets, timing, blah, 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 blah. The index underpins a default entry reader for random access into the underlying HAR file and a default HAR streamer. Yeah, that's exactly what it is. Oh. All right. This is stupid. Sorry, I just jumped straight over the strengths and into the criticisms. Let's read the strengths first. I haven't read them yet. What does GPT-5 think? GPT code, or whatever the model is underneath it, think of this. The index construction carefully avoids decoding full payloads by skipping large JSON subtrees, only recording the metadata needed for future needs. This keeps the build time and memory use comparatively low for very large HAR files. Hooray! Primary first principle of the entire application nailed. Great. The context can... I skipped over it. What am I doing? It's the string interning on the index reduces duplication of repeated values such as URLs and MIME types and connection identifiers. Love it. And that's a major problem for memory use. Major. The reader guards file access with a mutex, so random seeks from multiple Go routines remain safe, and the streamer statistics tracking uses atomics to stay race-free. Perfect. That's exactly what I want. Now, on to the critical issues. Critical issues. Sync.wait group is used incorrectly in stream indices. No, it's not. Stupid. This is, it goes to show how old the model is. wg.go does not exist. That is not right. Let's see when Go 1.25. August 2025. It's now November. Okay. So August. Where are we? Back here, yeah. August. Okay, doesn't matter. That is nonsense. The number one critical issue. Yeah, stupid. All right, the context cancellation path inside the producer loop only breaks out the select, not the surrounding for. So the loop continues and can deadlock the pipeline once context is cancelled. Oh, okay. That's actually genuine. That's a genuine problem. Where is it? Where is stream indices? Here it is. Stream indices. Okay. Return 4. Ah, yeah. There you go. Yeah. Okay. All right. Okay. Yeah. It's a simple logic issue there. Okay. That's valid. 3. The stream body always returns a no-op closer, which panics on the first read. Stream response body always returns. Where are you? Stream response body. Here it is. What does it say? What are you saying? Always returns a no-op. Yeah. Okay. Which panics on first read because the wrap streamer is nil. I don't know. The wrap reader is nil. And that is true. That is true. All right. That seems like a stupid one. How did I miss that one? I wasn't reading the code. Wasn't reading all the code. Wasn't reading it properly. Reader. Skipped over that one. I think that was a new one. That was me. All right. Yeah. Okay, that's a valid point. Number 4, read metadata interprets its offset parameter as an entry index. Okay. Enabling the cache to merely switches an ARP cache. I don't care about that. Cache hits bypass total reads counter. Okay, that's fine. Stream filtered and the stream range eagerly allocates full index slices before streaming, which can explode memory usage for large selections instead of lazily loading and pushing indices. Okay. And the worker pool deadlocks if worker count is 0. Okay, that makes sense. But sure, we can put some protection in there. Design and architecture concerns. Okay. It says the string interning shards are lazily initialized without synchronization. Concurrent calls to intern during index construction could race when 2 Go routines initialize the same shard. Okay, that's fair enough. Even though current, this Codex is really good for this stuff because we've run this code review a few times now through Claude and it's not come up with any of this stuff. So this is really good, actually. One of the reasons why I'm actually quite bullish on Codex, to be honest, for the future. It's still a bit slow, but this is good stuff. Just for the sake of time, what I'm going to do is I'm going to take a few of these. I'm going to get rid of that first one. I don't care about that first one. No automated tests or commands will run, as this was a static code review. All right, we'll keep that context in there because I think that's valid. Okay, I'm going to put this back into Claude. Let's go back over to Claude. Let's go to Claude. Come on, Claude. Let's give you some feedback. Feedback from one of your mates. One of your mates says about how you've been coding it. The design is good, but there are some problems with the code. The design is good. We've nailed the design, but the implementation is a bit rubbish. It's okay, but we can do better. So let's tune it out. Oh, I'm getting another error from Ghosty complaining about malicious commands. All right. Okay, before we do that, let's go home. Hello, Claude. I've run the code through another agent for a full code review, and it's come back with some interesting points. Can you review the points, look at the code, and decide whether or not you agree with the other agent's points of view? And tell me what you think. All right. Now we put them to the test and see how well they operate when now they're being judged. Your friends are judging you, Claude. They're judging you. They're pointing and laughing at you. Do you have the stomach for it, Claude? Can you take it? Can you take the heat? Can you take it? Excellent points from the other agent. Let me review each one systematically. Great. Let me verify each of these points systematically. All right, Claude, while you're doing that, I'm going to nip off for a second. I need to use something over there that requires some privacy. I'll be back in 1 minute. All right, well, let's see. My assessment of the code review. After reviewing the code, the other agent is correct on almost every point. Almost. Context cancellation deadlock. Agree. The break only exit. So we saw that. Yeah, we looked at that code and we agree. The stream response body returns a nil reader. It does do that and it will panic on the first read. Yes, yes. Read metadata uses offset as an index. Okay, we stop kind of looking here because a lot of this stuff is valid. The cache always is a no-op cache. Agree. Code is misleading. The cache hits bypass total reads. Return early without incrementing total reads counter. Okay, so we've just got a logic error there. Worker count is 0. And it deadlocks. There's no validation, 0 workers. Yeah, so some defensive programming wouldn't go amiss there. And the valid design issues, the shard init raise condition. Yeah, I can see that happening because if we have read buffer, the read buffer size is never used. Okay. Let's go, Claude. Let's fix all these bugs. Let's do it. I agree with all of this stuff. This is slop, and I'm glad we caught it. Thank you, Codex. Maybe not rub it in his face. Maybe not rub it in his face. All right. Terminal 2, Agent 2. Okay, Claude. Actually, I realize we don't have, let me stop there, I'm just rambling here. We haven't set up a Claude.md file yet. So I'm going to have to get Claude to read all this stuff here and then set all the context all over again. Which is a pain. So let's do that. Let's do that now. What we do is we'll get Claude to read the existing code base. And this is this is another reason why this is where work trees can be useful, because we can see that Claude is in the middle of editing stuff. And that editing means things won't compile. So if it's reading the code, going, this is wrong, or it's looking at it wrong, or it might read it wrong, and then the context is wrong, and just, you know what, let's just do it. Claude, we are working on Braid. We haven't written a Claude.md file yet. That's what we're going to do right now. I need you to read all of the code in Motor and determine exactly what it does, and tell me what you think it does and what your interpretation is, and then we'll move on from there. Okay, so we're going to start understanding what we've got here. We'll get the Claude.md file set up now. We'll add all the context in, and then we'll continue adding to it as we move forward, so this becomes easier tomorrow, and then the next day, and then the next day. We have to keep doing this over and over again. I need a different view here. I realise I've already got individual terminals, but I don't have terminal 1 and terminal 2. I don't have my agents running side by side. I need to bring that in. I tried it the other day with Ghosty and tabs, and it doesn't work. It just reads the same tab. If you flip the tab in Ghosty, it won't flip the view. So it's just looking at the individual tab in the window, not the window, which is just learning, things I'm learning about, doing all of this stuff, all this new muscle memory that I'm building as I figure this out. And I've definitely learned that I need a better mouse, more reliable mouse. It is turning on and off, being very annoying, randomly, for no reason, like nothing's happening. It just, and it's smooth as butter, and it's, you know, it could be the vacuum, it could be the microwave, I don't know what it could be. It could be all this. I mean, I've got a lot of stuff running on this desk right now. There's a lot of things moving, well, not moving. Electrons are moving through them, but they're not moving. But if it could move, it would look like there's lots of moving parts. But I'm sure it's giving off a huge amount of leaking electroradiation, electromagnetism, radiating out. Okay. What have we got here? What did you find? Let's have a look. Okay, after reading through the code in the motor directory, here's my interpretation of what this package does and how it works. Motor. What are half files? Okay. It's got that. It understands about that. Yeah. Okay, so it's figured out all of these pieces. All right, motor package. So it's a well-architected solution for a specific problem, efficiently processing massive HAR files that would otherwise be impossible to work with using conventional load everything to memory approaches. The design prioritizes memory efficiency and performance while maintaining clean abstractions and good test coverage. All right. I mean, it's the same LLM talking about the work it's already done, you know, so I'm sure it's going to feel like it's great. We'll see how Codex feels after we've made all these changes, and then it's going to re-review it. Yeah, so I'm going to say yes. Yes, Claude, what you have described is the motor package of Braid. It's the part that loads in HAR files and makes them available as a higher level API to the rest of the application which we're about to build. Can you add this to all of this context about Braid? In fact, let's add this additional context about Braid. Braid is an application, it's a terminal user. Actually, no, I'll stop that. We'll do it properly. Braid is a terminal user interface and a server application that allows the reading of large HAR files, i.e. we can visualize them and see them, see the requests and responses rendered out in a meaningful way, as well as being able to operate as a mock server and send back those responses based on the request so we can simulate a replay from client and server. Does that make sense? Razzle dazzling. That's pretty cool. Razzle dazzling. I like that. Where's that from? Razzle dazzle. That is from Chicago, isn't it? Chicago. Razzle dazzle them. Unless my memory's misremembering. I don't know. Maybe I am. Maybe not. Do I want to edit Claude MD? Yeah. Yeah, I do. I do indeed. The other agent is still just rolling along, just making loads and loads of changes. If you're interested in what it's doing, you can take a look over there. Tomorrow I'll get it side by side so we can see both agents moving together. It's buzzing again, sorry. Just checking what's going on. So what we've got here, Claude has written our Claude MD. Wow. Just looking at the Cisco stock this morning. Big old jump, look at that. Goodness. Ooh. That's fun. Created a comprehensive Claude.md file that documents the Braid project. Thank you. And includes this, all this stuff. Good. No, I don't want use cases. No. Okay. Hey, Claude, can you get rid of 0.7 and 6 and 4, please? Don't want future enhancements. No. I don't need use cases or development guidelines. And none of that is important. I mean, it's important. It's very important, but it's not important right now. Don't care. Not right now. Doesn't mean anything right now. All right. So if we go back over to our other Claude 1, and Claude 1 says, all 13 bugs fixed. I got it. I did this, I did that, and I did this. The the context cancellation deadlock, cleaned it. The string response body has been cleaned. The read metadata API is cleaned. The misleading cache initialization is cleaned. The cache stats undercount has been taken care of. The eager slice allocation, we're good. And that defensive work account we need to add in there has been done. Now the design issues that we had with the shard, the race condition on shard initialization, we've got a mutex in there. Okay, fine. Read buffer size, it's removed from stream. Okay. Well, I remember saying that yesterday. I was like, do we need that? I think it was Opus cleverness, to be honest. Opus cleverness that we don't need. Initialize the ignores context. I need context checks before and after build. So we can cancel those long running index builds. Yes. Okay. Metadata flags removed, has error, is compressed, is cat. Yeah. I remember thinking about that as if it's gzip on. I was like, who cares? Why is that important? Why do we need that? Good. I'm glad. This is where Codex really shines. Has been shining for me. When I get it to do builds, it takes forever. But when it does the code analysis, it goes deeper and further than Claude does. It honestly does. You can see like we've been building this using Claude, and then like all these major problems that whilst the code will run fine and it will operate, it will break down at scale, or it will break down with edge cases. And these are problems that we've got to fix in the fundamental engine to begin with. And we would have gone out with an engine that works at about 70%. Now it's probably going to be, I would say it's way more robust with these changes. And look, we bumped the coverage as well. The motor module is now bulletproof and ready to ship. Okay, that's again a very, very bold statement, mate. It's like bulletproof. Do you know how hard it is to make bulletproof software? I don't think there is such a thing. I don't think there is such a thing as completely bulletproof software. The only time that you might see that is when you've got true assembly and very, very small. I mean, maybe not even small. I mean, there are some amazing Roller Coaster Tycoon. Think about that. Is it bug free? I don't know. Maybe. That guy was incredible. His name escapes me now. I should look it up. But all written in assembly. 75%. Let's do this. Let's get Codex to take another look at it, and then maybe we'll bump the coverage a bit more, and then we'll move on, because now we've got a Claude MD. We'll bring up the other agent in, or do we even need to? Maybe we can. I don't know. We'll figure it out. We'll get two pieces going. We'll get one agent thinking about the TUI. We'll get one agent thinking about the CLI. That's what we're going to do. We'll divide and conquer. But we're going to do another code review first. Let's go back to Tower. And in Tower, let's delete a bunch of stuff there. I need that. Modified that. Okay. The majority of the work is okay. Okay. I did it twice. Context done. Oh, I see. Okay. Is that? This doesn't look right to me. What is this? Why have we done this? I mean, it might pass, but that doesn't look right to me at all. I think Codex is going to pick up on that. Stream range. I should have really looked at this in the IDE, but I can't be bothered. Let's move forward. I'm being too fussy and slowing down. I need to speed up a bit. I need to be a bit more gung-ho. But I still need to get this part right. This is the most important part that we can't get wrong. If this is wrong, then the rest is going to be terrible. So we've got to get this right. But I also don't want... What is that? Got this name loop. Oh, okay, yeah. No, that makes sense. This label on that loop there so we can break out. Okay. The work account. Oh, okay. All right. So all this code is doing here is just using defensive programming to default it to 1 if it's not set, or if it's 0, because the 0 would create that condition, and then that's that breakout. All right. This looks fine, and it's just deleting there. Okay, there's hardly anything. Okay, this is all good. Nice and clean. All right. Fixes after review from Codex. Let's add all of this stuff in here. I'm just going to copy everything I had that was built, and we'll put it in there. There we go. All right, let's commit this. Oh, and this on that test. And Claude. All that, and I want to commit this. It's getting in my way. I might just exclude this for now. I don't think this needs to even go into the source, but we will include Claude because, you know, if you're using Claude, it's there, it's available, and it's all pretty good. We'll keep pruning this as we grow. So if you do check it out, and you've got all the full context ready to go. If you want to use this, and you won't need to do any of that work. We don't want to commit that though. You don't need that. All right, let's go. Off we go. Now let's go back to Codex and ask Codex to do another review. Okay, mate, we have made some changes. We've made some fixes. Can you pull the code again, do another full review, and give me your thoughts on it, please? You missed my mate. Okay, mate. Mate, I said mate, man. All right. Ignore me. Completing the task. Hash. All right, while that's going, I'll be right back. Just 1 minute. I'll be back in 1 minute. Okay. The streaming workers still use WG code. It doesn't exist. Stop it. It does exist. Okay. All right. Read partial. All right, let's. Still saying. Look, I'm just going to correct it. Can you do me a favor and update your context and take a look at Go 1.25 and the new wait group syntax and decide whether point 1 still exists in the summary. I'm not sure why you're doing this, but refreshing the repo, I don't need you to do that. But anyway, let's in the meantime, whilst it's doing that, let's go and take these other points and feed them back in. I think they're good. Okay, Claude. I think we did pretty good actually. Can we? We've got some more feedback for you. What do you think of this? There's that warning again. This is feedback from the other agent. Do you think it's valid, or do you care? Do we care? I think it's just worth investigating. Okay. All right. Well, yeah, it's cleared itself up now. All right. So we shouldn't have that problem moving forward. It's. I'm just looking at Chrome. Sorry, bud. I was reading a different window while you were looking at that agent, going through all of it. The codex agent has now updated its context, so it's aware that we're using the newer syntax in Go 1.25. Not the older syntax where we manage deltas and done state, or call done when we're done, usually through a defer. Let's go back to Claude. And while it's doing that, we can actually come over to our other agent that was working on our, and we can start looking at the Cobra CLI. Now we need to add a CLI component to the application, something that was going to operate as a CLI in a headless mode if we just want to use the server without a TUI. So to facilitate this, I would like to use Cobra. Actually, I need to go and get the URL. Let's bring up Chrome. Cobra CLI. There it is. If you haven't used Cobra, oh, you should be. This is Cobra. Cobra is a library for creating powerful modern CLI applications. This is it. This is what you want in Go. If you're building CLIs, this is the tool. It's used in the Kubernetes, Hugo, GitHub. Oh, everyone uses this one because they should just put this in like 193,000 project, 194K other users. I mean, it's like this is it. Prime engineering right here. Prime software engineering. So we can use Cobra. So let me bring that back over to. Oh, hang on. I'll bring this over to this agent. We get that one going. All right. Let's use Cobra. Can you check out the code, read the docs, and understand it fully, and let me know when you're done? And while you're doing that, we can go back over to our other Claude. And it says, my assessment. The cache remains in OAuth. The construction ever wires cache. Its working is intended, and I agree. That is right. We don't want it to do anything. Number 2, read at with length 0, reads to end of file. It falls back to passing an end of file when offset lookup misses. It's a real bug. This is dangerous. If the length is greater than 0, limited reader. Okay. Else, read to the end of the file. Yeah, that's stupid. Yeah, okay. Because we'll just suck up everything, or the whole point of a tokenizer will just be completely void at that point. Yeah, that's ridiculous. Good catch. Find length for offset, return 0. Labeled break, good catch. Good catch. Fix this. Encoding ignored. We return the raw content string without decoding base 64. Yeah. Yeah, that's right. All right. Yep. Yep. Fix number 2. Over to our other agent. Here we go. It's done the research. What Cobra is. Cobra is a powerful Go library for building modern CLI applications. It's used by major projects. Okay, I don't need that. We know what it is. I know exactly what it is. I've used it 100 times. But I do want you to know what it is, Claude. I want you to know what it is. And everyone out there, if anyone's watching, I don't know, or anyone's watching this later, but this is it. This is the king. This is the king Cobra. The king of all the CLIs, CLI frameworks, if you will. It is a framework. It is. It's a very, very thin framework, but it is a framework. And how this fits Braid. For Braid, I envision a CLI structure like this for you. We're going to have serve, view, analyze, and version. Serve, view, analyze. Half file to analyze. What do you mean analyze? I don't want to. What do you mean analyze? View and serve is what we want. Version is what we want. Analyze, you're making that up. I didn't ask for that. I don't know. Headless analysis. What analysis? We're not doing an analysis. This is a viewer. This is much simpler than that. If we go back over to Terminal 1, it's asking a question, saying, it's doing a test. Yes, do a test. Back with agent 2. Okay, so we need to get rid of the analysis concept. Root serve. Okay, CMD is a standard design pattern. So this is a standard. I'm just gonna zoom in just a bit more so it's easier to see. Yeah, so CMD here. This is a standard design pattern, and these are going to be a root command, which is kind of how Cobra works. Is you create a root command, and that's then your super command that has all of your global flags and stuff like that. I just heard. Oh, yeah, I just had somebody a new mailing list subscriber, Mitchell Lloyd. Thank you, Mitchell. I appreciate that. Ooh, transitions. Yes, there are transitions. I got quite a few transitions, by the way. I'll show you some more. I've got grid wipe. I've got flyover. I've been using the flyover a bit. I'll do that one next, and then we can try something else. What else we got? It was fun. RGB channels. Oh, that's going to do some kind of retro video. I have not seen it. I don't know what it is, but we'll try in a minute. Right now we are just reviewing the CLI very briefly. Excuse me. Looking at the global flags. We're talking about the root command and how Cobra works. And quiet, verbose, yes. This is just standard debugging. Config file location. What would we need to configure? Maybe the breakpoints. But then, I don't know. Okay, yeah, I don't think we need that. All right, so, okay, so we need to get, oops, let go of the key. Okay, Claude, so we need to get rid of the concept of analysis or analyze. That command doesn't need to exist. I don't know what it is. But serve and view, yeah, quality. Leave them in there. That's what we need. We don't need a configuration right now. The verbose is good. Let's just get rid of quiet for now because I don't know what that would mean. Verbose is good. We don't need config. Can you then set up like a basic stubbed out architecture for all of this based on this requirements? Because then we can start filling in the logic a little bit later and bringing in a TUI and all that kind of stuff a little later on. But let's get the shell, the skeleton in place first. Now, before I actually, hang on. Before we do any of that though, do you have any follow-up questions for me? Let's let that think, and while we're letting that think, we'll run over to our other, oh look, did you see the RGB transition, the like retro video? Like, I'll do it again. It's pretty cool. I mean, it looks pretty cool from what I'm looking at. I don't know. I mean, you tell me. Let's try a different one. Vacuum. Ooh. No, I tried that one actually. It's rubbish. It looks very, very 1998. I mean, they all look a bit 1998 to be honest. We'll do 3D plane next. That should be like a box or some kind of spin or something. I'm assuming anyway. A bit old hat now. Been around for a while. Over here, it's telling us like issue 1. It's all good. He's nailed it. My fix. Nailed it. Let's commit the code. Let's go to tower. We'll go to tower. Just take a... Oh, there you go. Look, it did a flip. Like that. Maybe I need to put like a background behind it of something funny. So every time we do a transition, there'll be like there's some kind of hilarious background. That's an idea for tomorrow. That's an idea for tomorrow. Not today. Not today. What do we do? Reader. Okay, so in the reader... Yep. Checking the length. Limit reader. We don't need... Oh no, we're doing the length here. Okay, so it's a braid glass up the top. I'm going to escape early. So we don't go through it. Yeah, it's just these are just basically off by one error checks. More defensive programming. That is what you should do, but you often forget to do when you're prototyping. Addressed defensive programming issues. Let's push that up. I'm going to get codex to bounce it one more time. And see what happens. Let's see what happens. Oko, code. Oko? That's not right. Oko. Okay, it came out okay. Okay, codex, my co-pilot buddy friend thing. Let's do another review. Can you pull the code for me? I just pushed it. We've made one final change. Let me know what you think. The rest we don't care about, but what we've changed we agree with. Let me know your thoughts. Okay. Off you go. While it's doing that, we're gonna swap back to our other agent. We've been asked some questions. Before I set up the CLI skeleton, I have a few questions to make sure I build it in the way that you envision. How do I envision it? We're going to have a har file input. Should the har file be a required flag like --har, file har for both commands? No. No, that's silly. Or a positional argument like braid serve file.har? Yes. That is exactly how it should be. Or a different... No. So, question 1, the answer is B. A positional argument. As to project structure, do you prefer a cmd/directory with separate files for each command, or keep it simpler with everything in the root directory for now? No, we're going to do it clean from the start. Question 2, the answer is A, in the cmd directory. Not capitals though. All right. Question 3. Serve command specifics. The default port of 8080. That's pretty common. Let's do something different. Ooh, I've done 9090 already. I've done 8080. I think wiretap defaults to 8080. Oh, goodness. We can't do 5432. That's Postgres. How about 6543? 6543. Now, yeah, let's do that because it's random enough. 9876. 9876. 98. Let's do that. Let's just do that. Unless anyone can tell me it's a bad idea. 9876. That's the default port for now. Question 3. The default port should be 9876. And the second question is, for now, no, just leave them. We'll fill them in later. As we need more flags, we'll add them, but we'll only include what we need for right now. Question 4, the view command. Will this need any flags beyond the har file input? No. No. Oops, I can't just say no, can I? Question 4, no. Question 5, verbose mode. Should this control debug logging through the motor package too, or just CLI verbosity? Question 5, all logging throughout the application. All logging everywhere. So we need to make sure that we set up a global logger for the app. Speaking of, we should use syslog for that. Structured login, slog. Use the structured logger from slog from the default package. Sorry. Standard library, not default package. Standard library. Library. Not s-log. In the standard library. Question 5, let's give you a space there. And question 6, binary name yes. The binary command should be braid. Go. Off you go. Off you go. Let's go back to Chrome. And in Chrome, in Codex, it says the two things are fixed. So let's ask you a question. How confident are you in this code now as it stands? Oh, let's just check it all out again. Well, because why not? Why not? Let's just waste a bunch of compute. All right, and we can see what the other agent is doing. What are you doing? Oh, you're doing nothing. You're waiting. You're waiting for something to do. You can wait. What are you doing? We are building out the CLI. You know what? We're doing that. You know, let's leave that. Leave you alone. Let's come over here and what we are going to do over here is we're going to compact, and we're going to bring in Opus again to do the next bit of planning. The reason why I didn't bring in Opus for the Cobra is because Cobra is just it's more than likely already in the model without needing to look at the docs. It's so widely used as a framework. It's so widely used. Yeah, I don't think Sonic can just use it fine, just fine. There's so many examples of how to use it, and the API is so clean. It's just we don't need it. But what we are going to be doing next is we're going to be having Opus review the code I've already written in Vacuum. When I say me and Claude wrote it. But that code is exactly how I want this code to look in Braid. It's clean, it's efficient. I spent hours and hours and hours fine-tuning by hand because I couldn't get the LLM to do this. But make the rendering, the ASCII codes, understanding the design, the flaws, the problems, and trying to get it to render right, and then getting it rendering on Windows. Oh, Windows. Oh, man. Like a nightmare. Had to redo so much of it because of that. I had to rebuild it a few times because it looks great, looks across all the different terminal emulators on a Mac. Oh, it looks fine. Windows, doesn't right. It's just pipes all over the place. And anyway, I'm not going to go into the details because it's long and laborious. But I learned a lot. We wrote a lot of design guardrails in place to fix all those problems, and I want to basically lift all that thinking out of Vacuum and bring it straight into Braid. All the hard thinking's already done, and it's got most of the components. In fact, it's got more components in it than I'm going to need, to be honest. But the reason, one of the other big things is things like color coding and highlighting and text highlighting, using ASCII codes. We need to do that in Braid, and I don't need to be going through that learning experience with Claude today. It would take 4 or 5 days of pain. Not interested. So we're just going to take the learning from Vacuum. We're going to read all that code. We're going to load it into context, and we're now going to give Claude everything it needs to build what we want in Braid. That's the plan. But we have a fully working, operational, production-ready piece of code that does it. So we've got something for it to look at and copy and use. I'm getting buzzed again. Oh, I got a message. I got a message. I can't show you the message, unfortunately. Oh. No. It's a bit of a distraction. Something I can't help with right now. So, that's the goal for the next piece. And also, My phone is buzzing a lot. I need to turn on Do Not Disturb in a minute because it is annoying me. Buzz, 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 buzz. Go away. Go away. Go away, people. Buzzing me, asking me silly questions. Set myself to away. I'm not here. All right. I am here, by the way. I am here. If you're watching me, I am here. I'm just a grey circle now on Slack. Because people are going, where's that thing? Like, well, it can be dealt with later. It's not important right now. What is important is this hackathon. Hacking code. It's what I enjoy the most. Even though I'm now hacking through an LLM, it's still hacking. And it's faster. Because we're getting quality code out of the gate as we move forward. So anyway, I'll stop my rambling and we'll just take a quick look at the other agent that is telling us that it's done a bunch of work. It says the CLI skeleton is complete. I've successfully set up the Cobra-based CLI architecture for Braid. Here's what I created. We've got Braid at the main.go, which is critical. We've got the command, we've got the root, the serve, version.go, using a global logger, which is slog, which is structured logger, which basically means it gives us JSON structured output if we want it, or we can then write our own logger for it, and we can format keys and values and all kinds of good stuff. Really, really great upgrade to the Go library that was made a couple of versions ago. It really solves the problem of which logger to use, because there's a lot out there in Go, and they're all like at various stages of decay. This is good. It's good. Command structure, braid serve, half file, start the mock server with the default port of 9876. Braid view with a half file. It's going to open up that TUI that we're going to learn about in a minute. And once we review this code first, we're going to have a quick look at the code. It should be very simple. Very simple. Half file handling. Might have wired it up already. Global flags. Let's go take a look. Let's go take a look at the code. Let's see the code. Show me the code. Let's have a look. All right, we have command, and these are our new files up here. So the first thing is root. Zoom in. I'll make this a bit smaller. Okay. So this is the root command. We don't. Come on. We haven't run the performance code reviewer. You know what, I'm going to tell it to do it. While we're looking at this code, we're going to get the performance code reviewer agent coming, because there's all this stuff like this just drives me nuts. Why did you add that? I've built an agent to handle it, so we're going to get it to handle it. Did you run the performance -code -reviewer agent? I don't think you did. Can you run it now, please? There he goes. Now it's running the performance code reviewer. So whilst it's doing that, we are gonna just go over and review the code. We've got the root command, high performance half file viewer, mock server, braid is a terminal user interface, and a server application that allows reading large half files. I'm gonna set up logger. Okay, so we initialize. Okay, that might be a problem. Don't know why would you need to do it twice? We're running the init flag. Yeah, that's like a problem. Well, that'll probably be fixed. Hopefully the code reviewer will fix it, because that doesn't look right. Running this twice, we don't need to run it twice. Unless I'm misunderstanding something about this. Okay, these are just logging stuff. Still login stuff. Validate with context. Okay. That just seems like fluff. We don't need that. Validate the half file. This is coming from the root. This is some. It's built this in to, you know, to ensure that we've got some basic error checking in before we even start about thinking about executing any logic. It's, does this file exist? Does it have the right extension? For example, we should get rid of that .har file. That's. Does that matter? That doesn't matter. It doesn't matter what it's called. You can call it whatever you want. That's silly. We need to get rid of that. Okay, that's all fine. View? Let's take a look at view. Let's have a look. Let's see what view says. So, view is a child command of root. And this is what's actually going to spin up the TUI when we build it. Hang on a minute. What are you doing here? Half file loaded. Logger. To do initialize and launch TUI here. Right now it's just printing out. Okay. So it's just what it's doing here is just printing out for right now is stub code, some information about the half file. TUI view is not yet implemented. Use braid serve to start the mock server. Great, that's what we want. And then the server, start a mock server with the half file. You know, we need to. No, actually, this is fine. This is what I want. This is what I want. I want the TUI to operate in both modes. And I want this to be like a headless, where it just runs as a daemon and you don't have to worry about the TUI because you don't care. You just want it to operate like as part of a test suite or something like that. So we do need this. I think this is the minimum we're going to need. What's this? Port 3. Oh yeah, that's things you want to override the port. Okay. All right. This isn't doing anything. Basic check-in, initialize HAL stream. What's HAL stream? Oh yeah, that's the. And then we got the initialize the mock HTTP server. Let me just test that out. Interrupt signal channel. Yeah, there's nothing here. It doesn't do anything. All right, that's just basic. Set up an HTTP server eventually and do nothing. Just going to sit there and wait for like a Control C or something coming through the OS. Yeah. All right. Okay, there's nothing in there. It's great. Exactly what we want. And view. We already looked at that version. I made a bunch of changes in Vacuum not too long ago about handling versions because there's all kinds of use cases and edge cases I wasn't aware of, and it mainly relates to downstream third-party engine. I don't. We describe them as porters, package maintainers. I don't know what the right term is. Just open source friends who are repackaging and recompiling the tooling for different systems. And they don't necessarily take the stuff that I've got from GitHub. They're going to take the source, they're going to recompile it specifically on that system or that package management tool, and then deploy it downstream. And I had no idea. I was like, what's that? It's like, where's that from? And I learned so much about all these different providers and what they do and how they repackage and what they need and what they don't need. And, when I go ahead and I'm just going to bloody change all of this stuff. And then I get all these issues appear going, it's broken. You've broken this. I was like, well, all I've done is just change the versioning command. Why would anyone need to what? But, or the version had that, how it actually picks up versioning and control versioning. It's like, why does that matter to anyone? this is stuff that I use. And then I learned, it's like, no. Actually, we all use it. Like, oh, wow. Okay. So that's a long way of saying that we're going to need to do some more work here at some point. This is not, this bit here is not complete. This is something that's going to need to work. Okay. Just looking at, not this, I'm looking at this right now. Oh, I'm not looking at that. I am looking at this. Okay. So, the performance, we ran the, are you still jumping up and down? You are still jumping up and down. Sorry, I was still printing stuff as I was scrolling. So the performance review issues have been fixed. It's addressed the critical issues for dry violations, context handling. Yeah, it's the stuff that I was talking about. Or no, I was talking about the init. Did it find the init? Let's see if it got rid of that in the root. Setup logger. I need to look into that in a bit. Port validation added. Unnecessary comments. Yes. No, look, you still left the drunk, mate. Drunk. You still left a bunch of nonsense in there. Why have you still left comments like this in here, Claude? I mean, this is what the performance code review is designed to catch, and it's still leaving like cruft like this in here. What are these comments about? Get rid of that. I don't want him thinking that I'm complaining about the properties, because it will probably get confused and think, oh, I'll delete those then, shall I? And then all of a sudden everything's broken. Oh, I've broken it. Let me refix it and then completely mess it up before we've gone in out the gate. But I am annoyed that these types of comments here is like global logger. Okay, I see that. It's in the root package and it's called logger with a big capital L on it. It's obviously a public global. It's in the root pack anyway. You just gotta remember that these LLMs are very smart, but they have no experience whatsoever, and they're also neurodivergent, and they have a string of letters after their names that describe its many conditions. You just got to be patient and remember that not everyone is inside your own head. Well, I've got to do that anyway. Maybe that's me. Maybe it's just me. Maybe it's just my fault. And while we're letting... Oh, it's done. Oh, I was just going to jump over something else. Okay, you're absolutely right. Those terrible, obvious comments had no value whatsoever. Yes. Yes, these are exactly the kind of pointless comments that clutter the code and make it harder to read. They're basically just restating what the code already clearly says. I know, Claude. I made an agent to stop it. But even then, you're still doing it. Okay. Well, thank you for cleaning it up. Looking a bit better now. Warning only. Okay. Alright, this is good enough. This is good enough because that's all it needs to be. Let's commit that code. And then what I'm going to do is I'm going to set the other agent off on a learning mission to start reading the TUI code in vacuum. And I'm going to take a little break. I've been going since 8:30 this morning, and it's now 12 o'clock. What is it? Only 4 hours, so I need just a little break. And if my stupid wireless mouse will catch up, then I can actually go and show you what I'm going to be doing. I do have one on. I have a wired one on order. Adding all this stuff here has messed up something in my environment that has just set my mice off. They're not working very well. And I don't know what it is. And to be honest, I don't care, because a wired one is much better anyway, in my very humble opinion. Oh no, we're gonna commit some code first, because we've already taken a look at it. It all looks fine. So we have now in our Go mod and our Go sum, we've added Cobra and pflag and mousetrap. These are dependencies of Cobra, not very many, and they're all good. And these are actually mostly indirect anyway. They will come directly from Cobra. And why are you saying indirect? That's not true. You know what? I'm not happy with that. I'm not happy with that. Let's go back. This is not. Let's fix this. Go to 125.1. There you go. Well, let's do just whatever. This is not indirect. How can it be indirect? We directly need that, and we directly need Cobra. Let's do that. And those three might, but well, let's have go mod tidy clean those up. I'm sorry, I'm editing code. I forgot to switch back over to the code editor. I'm just modifying. I'm modifying this stuff so you can keep this clean to begin with. I'm editing the go mod file because it's got some comments in there saying these things are indirect, but they're not. You know what? We'll just add this in because how the hell can that be indirect? It's not indirect, is it? They deliberately want these things. Now, mousetrap is indirect and B flag is indirect. Those two are indirect because I'm not directly calling them, but those aren't. Right. Let's see what happens when we do a go mod tidy. Yeah, that's right. You're being strange, go. Or that was Claude. That was Claude being. Maybe that was Claude adding those bloody. Maybe, I don't know. But this is the way it should be. These two are indirect. The rest are not. All right, great. Let's go back to tower. I'm gonna need to add a button for tower because. Moving in and out of this workflow is slow, so I need to get a little control or a little stitch stream deck down here. I can press buttons on it. Makes my life much easier as I learn how to do this properly. All right, this is better. This is better. This is better. Don't need that. Don't need that. Main.go. It's basically just call in the root command, and in CMD, and in CMD we've got root, and this is our root command. We've already looked at it. It's all fine. Doesn't do anything, except it does have the streaming code in here. We'll probably have to we'll refactor this a little later. I don't know what. Yeah, we'll change this a little later. We don't need to worry about it right now. That looks good. All right. Added Cobra's CLI to the project. Looks good. All right. Now we're going to move over. Not to this. To this. And we're going to tell Claude to go and read all the code in vacuum. All right, Claude, I want you to go and take a look at all of the TUI code in vacuum and understand how we've used it and how it's been composed and get a full understanding of the architecture. Look at that. Look at that. It mixed in vacuum and quobix. That is interesting because I didn't say the word quobix. I said word vacuum. Either that's in the LLM or there's some, I don't know what's going on there. That was very interesting. I've never seen that before. But if an LLM is now associating the word vacuum and quobix, oh, that's a win. I'm hoping it's just stupid local context, but that was cool. Take a look at all the TUI code in vacuum. It's in vacuum. TUI, and understand how we've used it and how it's been composed and get a full understanding of its architecture. Oops. Read the code and see how it's been used in vacuum to understand the use cases, and let me know when you're done. Oh, hang on. I want to add some more. Also, it's important that you read the code. Excuse me. The code for Bubble Tea, the TUI library, and Lip Gloss, its styling companion library. And in fact, all of the companion libraries used by Bubble Tea. Please understand how they work, and more importantly, understand that we're using the V2 of the library, and it's currently, I'm going too far now. So just for everyone's context, the V2 library is different. It adds a bunch of new features that aren't available in the current release. There's a new release candidate out for it. We're using an older release candidate. In fact, I believe this is just me, from me understanding and me rereading the code and me looking at the project, that Charm have a really nice TUI, basically like what we're using right now. It's like Claude Code, but it's called Crush, and it's an open code or router, or an open router, whatever it is. Not open code, sorry, that's another project. I mean, open router. It's one of those, like T3 chat, those type things of, hey, here's all the public models, here's a nice interface for accessing them. That's the value, is the interface to accessing the models and managing the models. And there's a bunch of these tools out there, and Crush is one of them. And it looks really nice, really nice. And they're using Crush as a test bed for their new version 2 of the Bubble Tea and all the Charm bracelet things. They've got all that lovely stuff they've created. There's loads of it. There's VHS. There's a logger. What's called like Skate or something. I don't know. There's a whole goodie bag. If you haven't looked at Charm, please go and take a look at their stuff. It's amazing. We can take a look at it in a bit if you want. Actually, I'm going to take a break first. But anyway, I'm going to ask the agent to look at Bubble Tea, look at lip gloss, all that stuff. But we're using the same release candidate. I don't want. Actually, maybe we do. Yeah, let's do that. In vacuum, we're using an older release candidate of the library. There's a newer release candidate of the library. Can you take a look at it and see what the differences are? And actually, do I care what the differences are? Yeah, let's see what the differences are. Read all the code, get a full understanding of everything. Excuse me. I need to clear my throat. Sorry about that. So I need to read all the code and get a full understanding of everything. Let me know when you're done. Let me know when you have all the context. You know what? I'm gonna do this. I'm gonna switch over to Opus first. I want to copy this because we made this mistake last time, and we lose all of this. We go up and we start mucking about. Oh God, there he goes. Go up and down. And we can edit the con. No, I forgot. It's Control G, isn't it? It's Control G. Alright, should remember that for next time. Model, Opus. All right. Let it go. I'm gonna let that go. All right, so Claude is now, yes, all reading. So he's going to go and read everything and look at everything and read up the docs, hopefully. There is that bloody search again. Man, that tool use is driving me nuts. Stop. It's some feedback. If you're watching Anthropic, please stop this web search jumping in. Read the code. Read the code, man. All right. I need to tell it where to look. So let's go over to Chrome here. And God, my mouse, it's giving me grief. It's charm bracelet, and then we've got bubble tea, and then there's we're version 2, but this is the latest stable is 1.3. It doesn't have any of the stuff we want in there. Now there is these release candidates. So last week, hang on a minute. The same one we're running. We're still running RC1. I thought they'd updated it. But you thought they'd updated it 2 weeks ago. No, they have updated it. Oh, in the beta. 2 weeks ago. Last week, RC1. I think that's what we're using. I think we're using RC1. All right, let me just... We're using this version, the release candidate one, and I click it, I come in here, I just say here, so you can hear. Stop searching. Stop looking on the internet, it's right there. One of the great things about this version of the library, the new stuff, version 2, is that they've got overlays. And I've tried to create them manually, and it's really hard. I run out of patience, and they've done it. They did it, so it's great. Yeah, I created it out without using bubble tea, and I tried it with bubble tea, and it's just like it didn't work. Actually, I created it in version 1, and it didn't work. I simulated it, almost worked, but it didn't work. Not on Windows. And then I saw they were using it I saw that they had all these cool features when I was reviewing Crush. I was like, how are you doing that? How are you making those things? And I looked at the code. I was like, oh, you're using an unreleased. Well, it's not unreleased, but you're not releasing it. You're releasing a pre-release code base. Okay, gotcha. I see your game. So I copied them, and I used those pieces that I wanted in Vacuum, and it worked. It took a while to get right, but it worked, and it works. It works well. So I'm going to do the same thing again. Because why not? Because why not? Why not? It's the right thing. Okay. I just realised that Claude is off. Claude is reading all the code. I'm going to go take a break. This is going to take a while. I'll be right back. I'll be back in 15 minutes. I'll be back at... the hour. I'll be back at 1:30 the hour. I just realised hadn't put my mic live yet. I just had a cup of tea. I hope you're doing okay out there. It's 12:31 p.m. my time. That makes it pretty early on the West Coast still. It's still only 9:30 in the morning. I've been going at this for a long time. We've been at this for 4.5 hours. We have got a few hours left. We're kind of definitely into the midstream now. Midstream. Feeling that part where you stretch your legs and go, did quite a good lot, but quite good today so far. Our engine is solid. We have a CLI wrapper. We've had a chat. Excuse me. And now we're about to see what Claude has made of Vacuum, the code base that I wanted to basically copy in intent, in style and design and architecture, but I don't want it to copy verbatim. It doesn't make sense. They're two completely different applications. But the essence of how I want them structured is, I've already done that work. I wanted to use it again, essentially. Design pattern in a box, if you will. It's an architecture that I would just like to just stamp and use it again, because it's great. Because I've just done it, like it's new, and I'm happy with it. So that's what does it say? It says the Vacuum 2E architecture. The implementation uses a sophisticated architecture built on top of Bubble Tea V2. Thank you. Thank you. Even though, I didn't write most of it, I'm still designing it. Cheers, Claude. Cheers, mate. All right. Here is what I've learned. Oh, beta 4. Although, oh wow, I thought I was using maybe RC1. I was using beta 4. Oh, okay. Yeah, I got that wrong. It's saying, yeah, you said, you're using RC1, but it's actually beta 4. That's my mistake. That is my mistake. The code demonstrates advanced TUI patterns. Uses bubble tea, lip gloss, and bubbles. That's right, because they're all different versions of betas. That's exactly right. The key architectural patterns, multimodal interface. This is what I saw in Crush, and I was like, wow, that's great. Oh, I didn't copy the code, but I saw how they achieved it using the API, and then I just built my own. We got view modes, modal types, using layering techniques. Yeah, it's great stuff. I want to use it again. There is, I wouldn't say it's complex state management. That's unfair. It's not complex state management. There's filters and whether or not you're viewing a modal. I wouldn't say that's complicated. Take offense to that. It's not complicated, man. It's simple. All right. File watching. Yep. Although we don't need that. Ooh, or do we? Because if we're thinking about the future, we don't need it right now because it goes beyond the use case of the first point of the product. But as a later extension, thinking about how to add more functionality down the road, and thinking about this, adding real-time monitoring with debouncing. What are we monitoring? A half file is delivered. It could be streamed. That's what we could be watching here. Yeah, okay. So we're basically watching for a streaming half file. Although that's not possible. It's not possible because of the way the half file is structured. No, I don't think we can do this. You can't do streaming with a half file. It's not like JSON-L, where you've got lines of JSON that you can just pass in as tokens. It doesn't work like that. Not with the way the HAR is structured. So no, we don't need that. We don't need file watching. Okay, we can wipe that off the table. The advanced rendering features. This is the part I'm particularly happy about. is the syntax highlighting, is exactly what we need. The code windowing, need that too. And the responsive layout, yes, this was tough actually, was to get this right. And the color customization with ANSI codes, that was the hardest part of all of it. Fighting those ANSI codes, like you'd enable something, disable something, and one thing would screw up the rest of everything. It would put a double escape in, or you put the wrong ordering in, and just that if you didn't get those codes right, which is fine if you're writing a string end to end, but if you're trying to like build an engine for generating ANSI codes, it's hard. It's hard to get it right and hard to get it balanced. And I don't care what anyone says. Oh, it's easy. You use this algorithm. I'm like, yeah, that's all good and fun. But when you want really fine tune it, when you really want to customize it and put, custom everything everywhere, breaks. It will break. It becomes fragile, and making it tough, making it hard, making it solid is tough. It's tough. It took me days to get that right, hours and hours and hours. And this isn't of like me mucking about with the LLM. This is like me doing it manually, like coding manually, of backwards and forwards and testing. Because it's not just it looks fine on my machine. You try over here, particularly Windows, blows up. So yeah, I want to take all this. I've already done all this thinking. It's not 2024, it's 2025, by the way. It's saying this. Vacuum uses July. I did build it in July. November. They brought it out this month. Okay, so the key changes in RC1. This is what we need to know. The module name is changed from bubble. Oh, okay. That's interesting. They're using charm.land/bubble-t because they've got such a large ecosystem of their own tools. That makes a lot of sense, to be honest. It makes a lot of sense. Message types became structs, not type aliases. Okay. That's a big change. Yeah, I know it uses the Elm architecture. Yeah, that's good. Yeah, that's good. That part's good. Okay. All right. Let's do this. Now that we've got a CLI in place, a hook. We're gonna use RC1. So those changes that have been added in RC1, we're gonna use those, which is changing the module name, it's a big deal. Okay, it's not a big deal. It isn't a big deal if you use refactoring. It's kind of a pain in the arse, though. It really is. I'm not gonna lie. I've done it a few times, and there's so many areas you don't think about that you need to get touched. So we use that new module name, and we're gonna start. I'm going to start with the basics. I don't want to overcomplicate this. We're going to get a build plan together. We're not going to build any code yet. We're going to get Opus to get a build plan together, and we're going to get Sonnet to build it. So let's ask Claude. Okay, Claude, we're going to put together a build plan. And this build plan is going to put the basic fundamental experience together, the shell of the TUI, so we can then start filling in all the pieces and the designs and things and stuff like that. So we do want to use the new release candidate, not the betas that I was using. If there's a release candidate, use that for version 2. Use the latest version, essentially. Let's see when that comes out. All right, that looks good. Okay, so let's describe what we want the window to look like. I'm thinking it needs to be a little bit like the experience I've created for Open API changes. Let's bring up Chrome, and I've got a screenshot of it in there in GitHub somewhere. Come down here. So this is not quite it. This view here, it's not quite it. Where we've got 3 panes in this order. I'm thinking more of a of a 3 panes, but ordered differently. The top part will be scrolling through requests and responses. So you'd have a request and response, request and response, request and response, request. And we'd have to figure out at some point some nice, interesting way to render those pairings together. So the in, the out, the in, the out, and show how they're related. Because they might not be in order yet. We might encounter that. I don't know. I'm not entirely sure. I can't remember how HAR is put together. We'll figure that out when we get there. But we're going to show that, like an inbox. You can go through and, scroll down and hit enter. Or even not hit enter. As soon as you scroll into it, it's going to load that data in there. For a good experience. It's kind of what we're doing with vacuum as you move up and down in vacuum. In fact, I can show you what it looks like in vacuum. I'll go back here and then come to vacuum. I've got the same kind of screenshot in here in the README. Use vacuum. Keep scrolling. There's our lovely sponsors. Thank you, sponsors. Thank you, all of you. There. Thank you for supporting me. I'm looking for this screenshot. Where are you? I know you're down here somewhere. There you are. There you are. So this is what it looks like inside vacuum. And it's kind of the same experience I want, but I think we need maybe a double left and a right. I don't know. We're thinking about you need to view request and response. You see do you want to see it side by side? Like request, response, and with the list on top? Is that going to be the most effective way? Or is it going to be just a list and then you hit it and then you'll just see the request or the response to be marked either way? But how do I know which one was which? If I want to hit a request and I want to see the request and its response. If I hit a response, I want to see the response and its request. I think that's what I want. That's what I want to see. That's how I would fix. That's what I want to see when I'm diagnosing things. I don't want to see the request and wonder which one is the response and then have to go up and down. Up, see the request, down, see the response. That sucks. I want to see left and right. And I want to be able to blow up the request or blow up the response and look at them individually and see them, without all the clutter around it, or as a modal or something. You see how it's like this is popping up modals. I'd want to do that. I'd want to do that modal pop up over there. I'd want to do that for code. No, or the request, not code. I'm looking at what I'm seeing and I'm saying out loud. I'd want to do it for the request and response, because right now here what we're doing is you're highlighting. See, I've already figured out all this code rendering. I don't have to go back and do it all over again. Oh, God, it's so much work. This is all custom stuff. Most of it is anyway. Yeah, I would want to load the request response in that, because then I can go through and I can hit another key instead of breakpoint. Basically want it to look like this, to be honest, mostly. Yeah, all right. Okay, that's going to be the command. Let's go back. So what we're going to need is a layout similar to vacuum, where we have a list of the requests and responses laid out like they are with violations in vacuum in the code base. But underneath, we're going to, instead of just having a single pane, when you hit return and you see a violation, you'll see you'll see a code snippet and you'll see all the bits and pieces. This is going to have a left and a right. So if you're scrolling down and you hit on a request, you'll see the request object on the left, and you'll see the response object on the right. if you hit a response, you'll see the same thing. So basically it's going to show you the pair no matter whether you hit the request or the response. It's going to show the left and the right in that bottom half. So the top half is going to be a list of the requests and responses in order as they're rendered in the half file, and then underneath it is going to be a left panel with the request and a right panel with the response. Let's just get that working for now. Well, that pasted text is quite a lot of text in there. So for this first iteration, we're just going to read in a small heart file. It doesn't have to be 500 meg or 5 gig. It can be like 5 meg, just for us to be able to get in a list of requests and responses so we can test out the layout. The layout should be like with vacuum. The top half should be a list of all the requests and responses, and the second should be broken into a left and a right panel. This should all be responsive as well and sensitive to mouse control. The left should be the request, the right should be the response, and let's just get that working so we can move the cursor up and down the list, and as soon as you select that item, it's going to load that body from the half file, and we're going to see the request and response. Don't worry about coloring right now or anything like that. Just leave everything as just standard white. We're going to bring in the same color theming. We're going to bring in the same color management. I want this braid application to look exactly like it does in vacuum. Same color, layout, theming, everything. All that hard work has already been done. I don't want to have to replicate it. So just use everything is all the colors, all the coloring and the theming, all the styles we have for lip gloss. We're going to bring them in, but don't use them right now. We're going to just leave it as a default color so we can get the layout right first and not overcomplicate things with primaries and secondaries and all kinds of stuff like that. Okay, that's a big blob. The goal is to just be able to call braid view and then a half file in the CLI, then the terminal UI pops up with a lovely bubble T layout with the top half of the list, and then you scroll up and down and you'll see that request and response rendered in the second half in the left and right panel. Let's get to that point and then we'll iterate. Ooh, actually, please just build the plan. In fact, I need to turn the plan mode on. Let me do that. Let's turn on plan mode. What was it? Control P or Control G? Was it Control G? No. Was it Control P? Or was it Shift? No. What was it? Shift Tab. There it is. Plan mode. Can never bloody remember these combinations. Like playing a freaking Street Fighter, World of Warcraft or something. It's like key combos. Man, I've never been good at the key combos. I've never been good at like playing video games where you remember all these combinations. Like, just the thumbs with the fires. I can do that very well. I'm always bad. No, keep it simple. Give me one control. I think that's why I try and make everything simple, because Shift Tab. Thank you. Yes, Shift Tab. Sorry, I just saw that. Okay. All right, I don't want you to start building Claude. That's a lot of block. That's a lot of stuff there, isn't it? Don't start building yet. Don't start building yet, Claude. We're just planning out the design and the strategy, because we're going to have another agent do the build. So plan it all out, what we need to do. But do not build. Just a full, solid and complete plan. And before you do that, before you build the plan, do you have any follow-up questions for me? Let's see. See what questions it comes up with. because this is the next. We can't finish today's session until we are able to run in the terminal braid view half file and see that half file rendered out, even if it looks janky and clanky. I'm sure it won't, because we're given some pretty decent starting material here, and we're pretty well. It's already well architected to begin with, and all the decisions have already been made. We've done that hard thinking. It's not like I was preparing for this or anything. Anyway, all the hard things already done, so it should be a case of let's just play copy pasta. Copy pasta in design style, not copy pasta in actual code, because again, as I said, they're two different things. I have several clarifying. This is what I love it when it brings in this tool. It doesn't always happen. It seems to be a bit hit and miss, but when it does, it's quite a lot of fun. Look, it gives you this interactive quiz. I love it. I love it. How should entries appear in the top list? Good question, Claude. As separate rows for each request and response, or as paired entries? So do you want to see them in the list like this? Oh, that is a good question. So how do we want to render it? Because it's like it's a ping pong. It's a ping pong. And having a ping pong on the same level, I think, is always difficult. You know, you want it to be like ping and to go pong, not ping pong, ping pong. That's not like this. It needs to be ding dong, ping pong. Or ding dong. Or should it? These are the interesting questions of the day. Should we have it on separate rows, or should we have it on the same row? And I think it needs to be on separate rows. I don't think having them together, I think we need to structure it when we do render it out. It's going to need to have some form of it looking like a chat window, like a you know, an iMessage or any kind of whatever chat you use. You've got bubbles left and right, not bubbles, no bubbles, but it has to be that same kind of structured, you know, you said this, I said this, you said this. Like any chat interface has to follow that standard. Why is my phone buzzing again? Oh, it is a LinkedIn article. Some LinkedIn noise. BS. Okay. Yeah, separate rows. Paired rows? No. Request rows only. Ooh. The plot thickens. Do we even want to see the response? Because it doesn't matter, does it? Are we overcomplicating it by putting in additional data and adding too much? Having the ping pong, we just need ping. The pong will be evident when you click, when you hover ping ping ping. The pong will be right there. Yeah. I think we got request rows only. Yes. List columns. Oh, God, I love this. This is such a nice interface. This is where AI is like, wow, look at you. I'm impressed. What column should be displayed in the list view? What column should we have in the list view? Oh, I feel like I'm at McDonald's. You know, it's like, pick your burger, pick your ingredients. No, not McDonald's. You don't do that at McDonald's. You do that at the counter. That's where you do that. Or Burger King. No, not Burger King. You have it your way, but, you know, not really. But the counter you can. You can do that there. I like this. Basic method URL status size. With timing. This is a nice problem to have. What do we want to show? Do we want to show the timing or detail so we can include the URL? I think that's too much. The URL, the status, duration, request size, response size. It's too much. It's too much. What do we want to see? We're gonna have to customize this, I think. We want to see the method. We want to see the URL. I think that's like, yeah. URL, but yeah, the URL's got to be there, but it has to be truncated if required. What else? The status. Oh, this is the code. The code doesn't matter. There is no code on a request. Yeah, but it would be for the response. Yeah. If we're doing it on one line, we're gonna have to. The size. God, that's a good one, isn't it? I don't think we need the timestamp up there. We'll put that in the rendering. With the method URL, the status code days. The duration, yeah, I think we need to know that. How long did it take? What was the round trip on it? And we'll leave the request size and response size for let's do URL path. There we go. Yeah, path. And then we can display the full domain in the rendering. So we got the method, we got the URL path. It's truncated if it's required, because those things could be query parameters. They can be just massive. And then we got status and duration. It's the what, it's the where, it's what happened and how long it took. What, where, what happened, how long it took. What else do we need? How many beers you brought to the party and how many were left afterwards. That's the request and the size and response size. I don't think that you need to see that as a status in the columns. It would just kind of be too many. That's good. That's good. I think we're good. Let's go. All right, what should we display then? Response panels. My goodness. Yeah, I love it. Okay, the headers and the body. Show HTTP headers and body content. Yes. Structured view. No, it's got to be structured. Yeah, I want to use structured. Structured view. Should we use the motor package? No, of course not. Why would you ask this question? This is dumb. Should we use the motor package we built in Braid for half file reading? Use the motor package is option 1. Leverage the efficient streaming and indexing we already built. Or should we just do a simple JSON load? Well, then what's the point of the motor? Claude, you're so smart. And then he's like, should we just not do any of this? Or should we do all of the stuff we've just been working on? No. Throw in the bin. Trash it. Stupid. Motor with caching. No, we don't need that yet. We don't need that yet. We're just trying to get the basics here. The point of today is to get this moving along the ground, bumping along the ground. Review your answers. This is great. Anthropic. Love it. Love this. Really nice. How should entries appear in the top list? As separate rows for each request response or as paired entries? We're going to do request rows only. We're going to do method URL path, which will be truncated, the status and the duration. And we're going to do the structured view for request and response, because that's the whole point. And we're going to use the motor package, obviously. Submit answers. I love it. It's like, here's your ingredients. Now throw them into the chaos machine and see what comes out. I'm always excited at this point. It's always very exciting to see. He's like, you pour a bunch of, I want it to look like this and go like this and move like this and it should do this and it shouldn't do this and it shouldn't do this and it will do this and it won't do that. And if you've got it right, if you've got the layering right, you've got the staging right, and you've built the context up correctly, this piece is like, it can be a little bit of magic, you know, like, wow, look at this. And if you did it wrong, you just get, you get a chocolate teapot is what you get. A chocolate tea, yeah, an underwater hairdryer. That's what you get. Yes, you're allowed to read from this folder. Okay, so we've answered all these questions, and it's going ahead. There's nothing more to do on the CNI side, so the other agent doesn't need to do anything. There's no code to review either. We are in planning mode for gear, and then once this is done, we should let it run for another hour or so to build, and we should end the day. We should end by, well, my day is going to end at 3. That means it's going to be lunchtime in the West Coast. So by 3 my time, 3, we should have a terminal. Well, actually, we're going to end as soon as the terminal UI is loaded, and we can scroll up and down, and we can see half file entries, and we can see them loading something, request and response in some of those panels. I'll be happy with that as the end of day 2. Go list -m. What are you doing? Okay, it's just checking the module information. Yes, okay. And that's the goal, is to get to that point. I don't want to do any styling, or I don't want to do any tuning, or I don't want to do any more work on the actual layout, the TUI and things like that. We'll start on that. We'll figure all those problems out tomorrow. We'll do another full code review as well with codex, and bounce backwards and forwards like we did earlier on in the stream, where we kind of, you know, get it cleaned up and get it refined and fix the mistakes and get it to a point where we're happy. We'll do that. We'll do that with this code, all this code that we're building today, and then we will continue. We'll refine it, and then we'll start working on maybe the goal for end of tomorrow. Well, you know what? We'll figure out what the goal for tomorrow is tomorrow. That's tomorrow's problem, not today's problem. While this is spinning around, I'm going to step outside and go admire my trees. I like to go and look at nature while AI is burning massive amounts of electricity. Just so I feel better about it myself. I'll be right back. While the computer is going brrr. I can see that you have been busy, Claude. RC1, we want RC1 with all the latest goodies. Please don't start mixing up versions. Please, Lord. Please don't do that. We do want the RC stuff. Yeah, you're gonna change that. Module that module. Look at this. Look, hang on. Bring up my code. No, T1. There we go. Now we can see it changing. It's starting to change. There you go. It's changing all the time. Creating the TUI package structure. You can see what it's doing over here. I can't zoom on this. I can't zoom on the file navigator. Oh, it's not letting me anyway. Oh, I don't know what it's doing now. Make the TUI. You say, oh, there it is. There's the TUI. There's our TUI folder with nothing in it. Let's just make sure that there's nothing in it. It's still building. It's creating the first file. Model.go. That's an important design piece of how bubble tea works. It's based on the Elm architecture. The model is everything, really. You handle events off of the model. I really miss the concept of MVC, and really it's just MC, to be honest. Oh, it is MVC. Yeah, I mean the view is like, it's just, I guess, yeah, you got to keep the C there, the V, sorry. The model and the view and the controller. I use that design still. I use MVC in Cowboy components for all the UI elements that I build. I still believe it's a super powerful, clean pattern, and I get why we moved to React. I see the advantages, and the real advantage is not that it's a better framework or that it's better technology. It's just much, much, much easier for people to get ramped up on, and for people to be able to learn. To the point where some people think that React is a language. Just goes to show, that level. That's the level of understanding of some developers that only know React because they think React is an actual web language or something like that. And that's why it appeals to a lot of people across the spectrum, because it's really accessible, and that's the key. That's why it took fire. That's why I caught fire. That's why Angular never did. Because Angular, while it is much technically superior to React, it's a batteries included approach, which I like, which is what Go is. The only problem with Angular, not JS, I'm talking about Angular, the revamp. I don't know what version it is now, like 400 or something. But the only problem with it is that it's designed like an enterprise framework, so it very much feels like it's a big Spring project. If you ever use Spring, it's like the fundamental framework they use in Java. And I'm still waiting for these files to appear in TUI. TUI, you saying you're writing files? I'm not seeing any files in it. It's probably a file synchronization issue. Or it's JetBrains. There it is. It is a file synchronization issue. It's just not loading. Let's take a look at the model while you're building. Oh, okay. Cool. Table. What's that? Oh, table. Hang on a minute. That doesn't make sense. Table's in here. Why would you do .table? Oh no, it's a bubble table. Oh, I see. Okay. All right. I'll just stop getting involved. Anyway, I was talking about Angular, and the reason why it never took off is because it's like a big Spring project. You ever use Spring? Super powerful. It's super powerful. It's you can do anything, and it's amazing. I love it. I loved it. Sorry, I don't use it anymore, but I loved it. And when I did use it, and Rod Johnson, very, very smart man. We worked together at VMware, although I don't think we ever met, unfortunately. But anyway, Spring was great, and it was exactly the same design pattern used by the Angular team. I'll put money on it. They were like, you know what, let's just make it Spring in the browser. And it is Spring in the browser. It's fantastic, but it's heavyweight, and it comes with a lot of pieces, and it's hard to configure, and it's hard to get up and running because you need to set this up and set this up and set this up, and all these pieces need to be in place. Or at least it was like that when I was working with it, which is, again, it's fantastic if you're building an enterprise grade UI. You need lots of people working on it. You need lots of moving parts. You got to keep adding new pieces all over the place. You need services, independent views, but you need a really clean way to bring it together. Angular is perfect for that. React, not so much, but React's appeal is not for that. It's React is like, you know, I've done a boot camp for a week, and now I'm a programmer because I learned how to do it in React. You can get all of these pre-built, prefabbed components and user interfaces, landing pages, everything. I mean, everything. You can get anything you want as a component in React. It's pre-built, it's prefabricated, it's ready to go, and it will work most of the time. There's, you know, material UI. There are loads of great stuff for building really phenomenal UIs. It's like it's the Lego store. The problem with that, in my opinion, is that you get so far away from like core principles of interactivity, like performance. And we've had endless problems at Splunk with performance in the UI. Not because we don't know what we're doing. It's because we're reaching the limitations of what things can have, how much data we can actually process in a browser and what we can do. And some of that is, you know, down to some bad technical decisions we made in the past, and some of that is down to, you know, real limitations in browser technology. And React doesn't help at all. It doesn't help because, oh, hello Dreams API, welcome back. We've been going for a while now, about 5 hours. About 5 hours. I'm just talking about React while we're waiting for Claude to go ahead and build out our new TUI, and taking all of my colors and all that stuff. Just getting everything set up. Everything's been built out, and then we're going to give it a nice dry run and watch it explode. And then we're going to fix it, and then we're going to watch it explode again, and we'll repeat that for the next 2 hours until it stops exploding. But in the meantime, React as a front-end technology, it's the accessibility, and it makes it popular, and it creates problems because it's magic. There's magic in it, and it's like, oh, there's all these abstractions. I don't like it. I don't like magic because we see problems where we're re-rendering a page 10,000 times because you're dragging a resizer, and it's a glitch in the way that using prop drilling and stuff like that happens in React. And oh man, the problems it creates, and you know, you can bypass all that with just some simpler designs, simpler architecture, simpler frameworks. So I made the choice years ago. I'm just following through with that, and very happy with that decision to not use React and to not use any UI framework. To be honest, I'm using just raw standards. I am using lit element, and if you don't know what lit element is, while we're waiting for Claude, let me. Do I have a browser? No, I don't have a browser. I'm just going to switch over to Chrome. Yeah, Claude isn't doing anything interesting. It's just building and failing. We're in Claude here. Let's go to lit element. Browser. lit.dev. Now, if you've never seen this, if you've seen this, sorry to bore you. If you haven't seen this, you should go and check it out. The reason why I'm a huge fan of lit is because what it actually does is it makes a lot of the work required to use web components. If you don't know what web components are, that's even more interesting. Web components. Do you want to do MDN? No, that's a lot of reading. Let's do webcomponents.org. That's nothing interesting at all. That's even worse. Maybe this is why web components have such a problem. Oh no, look, there's lit. Yeah, we got a marketing problem with web components. Maybe there's something useful on webcomponents.org. Getting started. There's an element for that. So, this is terrible. I'm sorry. I'm embarrassed now. It's not even my product. Web components. The base is the standard. It's actually it's a series of standards. Here they are. There's pieces to it. There's the custom elements, which allows you to define your own HTML tags. That's a piece that's required to enable web components. So that means you can actually create your own top-level tags, like, well, I don't know, everything that I've created has a PB3F prefix. You can then create whatever you want. It has to have a dash in it. You can't have a single tag. Or an underscore or something. It can't be a single word. That's one of the limitations that I ran into earlier on. You got to remember. Anyway, it's not super important. And then you've got, hang on, whilst I don't want to get distracted, we've got Claude is asking a question. No, don't read that. No, look in. Haha. All right, I was figuring that out. I was going to start reading the GitHub version, which is out of date, I think. All right, back to Chrome. You've got the Shadow DOM. The Shadow DOM is, if you don't know what Shadow DOM is, really important. Well, it's really important in web components. It's not really important outside of it. But it's like, essentially, if you've got the regular DOM, the document object model, which is essentially the structure of how what's rendered in the browser. It's the code behind the visual elements, essentially. The Shadow DOM is you could take like a button or any component, anything, any node, and then you create this shadow document object model behind it, which means it can be fully like sandboxed. So CSS, JavaScript, it's fully sandboxed in there. It cannot interact or interfere with the outer. Well, you can. There's ways to do it. But it's explicit. You can control it. But the whole point is it's supposed to be these self-contained little applications, mini applications that can be plugged in and portable. Now you can share all kinds of stuff. There's all kinds of interesting ways to configure it. But the Shadow DOM is supposed to be that. So it's your own DOM that you can manipulate without poisoning or polluting the parent one, which means you can bring these components in and they're self-contained effectively. You know, they've got their own styles. So like if you create like a component, a web component using the Shadow DOM, and you've got a global CSS, that Shadow DOM, component will be completely unstyled. There'll be no CSS. No matter what you do, you won't be able to style it. You've got to go and individually style those Shadow components. That's a drawback to web components, to be honest. But anyway, there's immense power in the Shadow DOM. It's a bit messy to work with, which is where lit element comes in. And you've got modules and you've got HTML templates. HTML templates are really, I don't know why. Let me rephrase this. If you've ever used React, you played around React, you've seen JSX templates, right? It's basically the same thing. It's where you can build in templated variables and functions. You can mix JavaScript and HTML together, just like JSX. And that's what an HTML template is. But it's a standard. It's literally built into the browser versus needing another library to handle it and do that translation layer. So custom elements, Shadow DOM, ES modules, and the HTML templating put together in a package. Those are 4 individual things. You put them together and you've got web components. And that means that those web components are based off of standards that run in the browser. So they are portable and they will run forever because they're standard based. There's no libraries to maintain. There's no like, oh no, we've got a mismatch over here, mismatch over there. Now there is lit element, right? I keep skipping over this. And what does lit element do? Well, what it does is actually create syntactic sugar for a lot of the functionality that you get from these 4 different technologies mixed together. Has quirks because they're not all great, right? They're not built great. And to use them and to work with them is a lot of boilerplate code, which is like, ugh. That's where, React is so like, oh, you don't need any of that. Just put this little bit of magic in and magic. But with web components, it's like, no, you must wire the big toe to the foot, which must be wired to this, which must be listening for this, which must be doing this. And it's like, oh, there's a lot of boilerplate for every single component. And sure, you can use inheritance versus composition. And anyway, I know I'm rambling here. I'm rambling about web components when really what we're doing is something completely different. It's a terminal UI. But I just love to talk about technology. Lit element takes away all of the boilerplate. It means so you don't have to worry about all of that wiring and unwiring. It all just happens automatically when you build. It'll just take, you basically use metadata and decorators. You decorate these properties that say, I want to make this reactive, or I want to make this stateful, or I want to, once you've done your first render, like first updated, I want to do this. Well, you can go, you've got all the different life cycle stages that you have with the React component, but it's just standard JavaScript built directly into the browser. It just, all the element does is just removes the need to worry about all of that metadata that you have to put in, boilerplate stuff, and it gives you this nice little decorator language. It just saves, it saves on boilerplate, and that's all it is. There's no runtime in there. There's no, framework that you're calling to be able to render things, and there's nothing of that. It's just when you build, it just sticks in the boilerplate for you when what's compiled in, and then you run it, and it's just regular, straight up JavaScript running against standards. That's it. No frameworks. Will work forever, and you're bare metal. You're as close as you can get. You're as close as you can get to the runtime. That's what I love. It's one of the reasons why I love Go, because it's as close as you can get while still having the beautiful, big, fat, comfy cushion of garbage collection and managed memory. So, perfect. The braid TUI Harvey has been successfully implemented. I'm dubious. It says the code builds without errors and all the components are in place. Ooh, hang on a minute. Did I switch the model and did we get Opus to build this? Because if Opus has built this, oh no. It's going to have antennas. There's going to be a swimming pool. There'll be a coffee shop in there somewhere. I hope oh no. Well, let's just, okay. Doesn't look like it's added a whole lot here. We still only have a very small number. And you've gone and done something. I can see you've done something stupid already. Right. I'm going to bring up the code. I was starting to look at that. No, that's the wrong one. That's the wrong view. This is the right view. We got, it's got the TUI stuff, but what is this? Oh, okay. All right. So I was about to start getting all annoyed. I was like, why have you created a TUI command? And I was because we've already got a view command, right? We've already got view. So why do we need TUI? And then I just started looking, and then there we got that. So it's going to launch the TUI, and what it's done is just abstract, pull the code out into another file. Okay, so I can get off my high horse now, and I can stop being up my own bum. All right. I mean, this looks clean. This does look clean. I'll go back in here, and this is all just login stuff. All right. Let's follow the rabbit hole down. Let's take a look at our model in here. We got our columns, Harvey model. This is going to be pretty bare bones. Again with the bloody strings on the cases. We'll fix those. Viewport, we're just updating the split. Oh, okay. We've got the commands going in. Yeah. know what, let's just before I just start, because I haven't seen any of this yet. We haven't run it. Let's stop analyzing it and let's do this. Let's do this. Catch you later, alligator. All right, we're in braid. So we want to do a go build braid. Go. Okay. My goodness, this microphone is in my vision here. Oh. Already got a problem. Before I get into this, it's saying it's already got braid view. Yeah, okay, you said you already built it. I'm not convinced, because there is a binary in there. Let's try. Oh wow. I mean, it looks like crap, and now the scrolling is broken. No, it's not. I just press escape. Oh, goodness me. I mean, it's not what I want it to look like, but we are not 10 million miles away. We're only about 5,000 miles away. Look at that. Look at those. We might be. Because this is exactly what I wanted to get to today. Is to this. Look at this. Right. Okay. Optimize for that larger file. Okay. All right. So this works with 5 megabytes, and it's actually looking pretty good. Let's level it up. Let's level it up. Hey Claude, initial view looks pretty good actually. I mean, it needs a lot of work, but the functionality, the basic functionality, seems to be in place for what I asked. I'm going to pause here because there's a question just come in on the stream. So to fill you in, I'm going to go back to the other terminal. What the request for today, well, not the request, sorry. The challenge for today is to get to a working terminal user interface that loads in a HAR file that we can then navigate, like we're doing now, up and down, and seeing all the. This is just a dummy. This is a generated HAR file that we had the AI make for us, and what we're doing is looking up and down and scrolling. Now this is just a 5 megabyte file. I'm going to go up and do a big file, a massive file. We're going to do a 5 gig file, but the whole point is to be able to scroll up and down like we're doing, and then if I click or hit enter, it's going to load up the second half of the screen. Will turn into like actually seeing the request on the left and the response on the right. So we can see it was a GET request with the URL, and here's all the headers. There was no body because it's GET, and then on the right you've got the response and the header and the body and all this. I'm going to render all this out nice and cleanly tomorrow. We're going to put it in, make it look a lot better than it does right now because it looks horrible. But you can scroll up and down and see the rest of that. If I do post, we should see a body. Oh, maybe not. That's problem. That's bug. Anyway, well, it's returning the body, and it's all just nonsense. Anyway, this is just a test. This is just a test file to show you that we can actually navigate the requests and responses, and our core engine, the horrific engine, is actually working properly, and it's gonna. Now we're gonna do the real test because we got 5 megabytes in pretty quick. I'm just gonna. We need to fix the double. So if I just run this again, it loads pretty fast. That was 5 megabytes it's pulling in, where it says 5 megabytes. Let's level it up. So what I want to do is I'm going back to my other agent, excuse me, And I am going to... Oh, I've just lost it. Yeah, the initial view looks pretty good. I mean, it needs a lot of work. It does need a lot of work. But the basic functionality is in place. So what do I want to do next? Next, I want to test out the experience with a big file. I want to do a 5 GB file. You said here the next steps, number 5 is to optimize for larger half files, like 500 MB plus. This is what I want to do. This is actually what I care about next. Okay, everything else is just cosmetic rendering and interactivity. For right now, I want to make sure that we have that HAR experience. So when I load Braid, I want to see it load up almost as quickly as possible with that indexing process taking, going as fast as we possibly can. So, if it's a massive file, you might see a indexing, please wait. And that's what we should do first, is run the indexer and print out to the terminal that we're indexing, we're doing something before we load the TUI. Actually, no. I'll change my mind. I'm rubber ducking this. I need to change that. Fine. Right. Yeah. No. Okay. Right. The experience I would like to see is the TUI to load immediately, regardless of the file size. And whilst we're doing the indexing, which is the slowest part, which is what takes all the time, there's nothing we can do until we've got that metadata in memory, and it's going to be like 0.6% of the size of the actual file when it's done indexing, which is a fair amount, to be honest. So while we're waiting for the indexing to happen, what I want to see is a spinner. Put in one of the bubble tea spinners, the same spinner we used in vacuum. Go and look at the code for when we're loading documentation. Use that one, and when it's done indexing, then load the TUI as it is today. The main view. I think that's good enough for that. Load the TUI as it is today. Yeah, and I want to test this with a 5 gig file. So do what you need to do and give me the command that I can then run for that 5 gig file, and we'll see what happens. All right, let's go, Claude. Let's go. Let's go, my friend. It's going to use our hargen file, a hargen application that we created yesterday for generating random har files. That's what we're testing, is the output of hargen. It's warmed up a bit in here. I'm going to take off my hoodie. I'm a little bit warm. So we're kind of getting towards the end of the day here. We're not going to be doing any more code reviews today because that'll be tomorrow's first thing in the morning thing, is a code review. But we are going to commit it. We are going to commit the code, so we've got it. And anyone can go and take a look at everything we've built today. You can take a look if you're interested. I'll push it on. It's all up to you. It's all on GitHub right now anyway, in the main branch. But I'll just push this stuff up so it'll all be there. And then tomorrow we'll review it, we'll clean it up, we'll bounce it backwards and forwards with codex, and then we will. Oh look, we are running Opus. Oh dear, we are going to run out of context. Look at that. Hang on, I'll get out of the way. Countdown is on. 3%. 3%. 3%, 2%. What we're going to do, bomb, it's about to go off. Yeah, if you want to learn more about Git, as I was saying earlier, one of the best tools that I use Vacuum. We'll be using it again in a minute. Is for using Git, for organizing Git. I just find it much more enjoyable than mucking around in the terminal with Git, to be honest. Love the terminal. Love it. But Git has so many switches and knobs, and I spend so much time like getting annoyed with I've done the order wrong or I've misremembered a flag or something. I just prefer the TUI terminal. We'll be over there in a minute. Thank you. I see the question. I appreciate your comment. It's like this is an awesome. It's awesome from idea to fully working app throughout your live app has been really important. Yeah, it's something that's been on my mind for some time. I've been wanting to do it, but it takes these types of things take a lot of time, and they do a lot of planning and a lot of work. It's a full-time concept to build these types of tools, and I don't have that much time during the day to be able to do this. You know, I've got some time in the morning, but there's a million bugs and other things I'm building. So to build something new requires a block of time, and I haven't been able to. You know, doing this during the day is a bit risky, because I should be working on other things. But I don't know, risky is the wrong word, but it's not. What's the word I'm looking for? Morally correct. You know, I shouldn't be using my employer's time for, you know, things that I want to do. But in this case is different. This case is just wonderful because this is actually something I'm building for the team. This has a real purpose, an internal purpose, but it's a generic problem that exists everywhere. So why not, you know, kill two birds with one stone? Actually give something valuable that we can use in our on-call situations that we actually need, that can solve a lot of real problems really fast, and also make it available for everyone else who has the same problem, you know, just by using completely free and open source. So having the opportunity to bring these two worlds together is really rare for me. This is why I'm making the most of it and doing all of this you know, live and doing it in public, because I want to share the knowledge. And this is years of experience, years of thinking, thought processes, workflows. I want to show you how I do it and how I pull it together, and the problems that I face and the frustrations and how we overcome them and how we refine them. And as you can see, the bomb has dropped. The bomb has dropped. API. Should have taken it out. Or Sonnet. I mean, Opus. Ran out. Sonnet with our 1 million context window. Let's go. Let's go, Claude. Let's go. That's another, like, a pain point as well. Like, if you're jamming and you're jiving and these short, small context windows just absolutely blow up. Like, you're we were mid flow there. We were generating, we're getting ready to do the next big test, which is an actual big file. And, you know, we might find that the big file doesn't work and we're back to square one tomorrow. That might be the, you know, we're like, oh, this is all great. We're making great progress, great time. You know, it's all on schedule, and then it's not going to work at all or explode. And then it'll be, actually, that's normally what happens, to be honest. That's normally what happened with me before AI. AI has changed it. I don't get to that point anymore where I'm like, it's working. You plug it into the system and it just goes dead and nothing happens. Or it freezes. The worst is where you just get like a deadlock. And it's what I used to find. This was back on my Intel Macs. I don't have them anymore. But when I was doing, actually no, I'd have it on my Windows machines as well. When I was doing some of the circular reference testing and design and debugging in libopenapi, so I'm just reading what Claude is telling me. Anyway, we'll go to this. When I was building some of the really highly cyclical recursive code for libopenapi, I was just using the debugger. There was no AI. There was nothing to help me. It was just me and, you know, the vast expanse. It took me a long time to kind of get that right, because get it. You work for 99 use cases, and I get to that 100th use case, and it's like, nope, no, I will not work. You know, if you go here and go here, then go here, then 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 here, and then you go there, then it blows up. Everything else is fine. There was lots of that, and lots of whack-a-mole. They're just things that you can't think through without, you know, oh. I mean, I build all these tests. It's like, it all works. It works fine. And then you dry out and it will just explode. It's like, why? That has gone away with AI. That frustration, which is great, because that's the part that I hate. You know, it's because I know it's almost right, but this is so complicated. I could really do with a second pair of eyes. And if I did have a second pair of eyes, it might change it, but I have no one at this point. Like, it's me looking at this code. You know, I've got no one to ask. I can say, hey, you, give up your time and donate it to me so you can look at my code. Like, no, it's the opposite when people want to, you know, commit to my projects. I'm like, hey, whoa. What are you doing? You know, I need to review this. This is no, yes. It's an inversion of control, obviously, but the other way around doesn't work. It's like, please read my code. It's like, no. So I don't have that. So AI has changed the game for me on that. Changed the game. Right now, what's this saying? It says it's done. The TUI now has a loading spinner that will display the index when being built, which is what we asked for. And it matches the Vacuum's implementation, that dot spinner. Yeah, I've got a dot spinner in there, which I built, which I like. Oh, no, you put pink in there. No color. Yeah, all right. I'm now worried that we've got random color throughout everything. Okay, now we've got it here. We've got a command. I'm going to run it in a minute. But let's just see what it says before. What's going to happen. This is what's going to happen. And if this happens, we're going to commit the code and that's it. We're done. How confident are you? I'm not. My confidence is low, but we will see. The TUI will launch immediately with the loading spinner, and the index will build in the background, and it will show building index with the pink dot spinner. When complete, it switches to the main table showing all 70,000 entries. You can then navigate and view request response pairs. The index build for the 5 GB file should take around 5 to 10 seconds based on our motor package benchmarks. 5 to 10 seconds? We can do better than that. Come on. And the experience will be smooth. No blocking, no waiting at the terminal prompt. And the TUI is responsive for the moment it starts. Okay, so it's got to be responsive. 5 to 10 seconds. You know what? Maybe 10 seconds isn't too long to wait to load 5 gigs. Or is my expectations out of whack on this? Is 10 seconds too long to wait to get 5 gigs of information in front of you? Maybe, I don't know. We're going to see how it feels. We might need to put some smoke and mirrors in place. All right, so let's go over here. And I'm just going to clear this, and we're going to paste in our command. And now we're going to run. I'm going to clear the chat just so we got as much real estate as possible. And okay, running. Responsive. Oh, hang on. No, of course not. I've got to build it first. You dummy. I was about to explode again. I was about to explode. Silly boy. Why are we getting upset again? Oh, hang on a minute. Well, we just did this. Oh, go, build, go. Oh, all over the place now. That's what I want. What do you... No required module provides package braid.go to add it. Go get braid. Why would you need to go get braid.go? What's going on in here? Oh, hang on a minute. What am I doing? It's main.go. Is it build main doc? It shouldn't be main doc. It should be braid. If that's my design, it should be braid, because then the binary would be called anyway. I'll do that first. This is the output file we want to put the binary into. So now we can run a command. You are not loading, are you? Yeah, big problem. 5 to 10 seconds. 5 to 10 seconds. 5 to 10. There you go. That's my confidence. See, look at that. Wrong. It took 10 seconds to start, 10 seconds to index. So I haven't even looked at the code, and just by the pattern recognition on this, is doing it twice. It's doing this twice. It has to be loaded in 13 seconds. That was not 13 seconds. That was 23 seconds or more. All right, let's get on to this. Oh, my mouse has gone all crazy again. All right. Okay, Claude. We tried it out and we saw the spinner, but it took 10 seconds to load, and then the spinner appeared for 10 seconds. So we're about right in it taking 10 seconds to index, but it seems like we're loading the file, indexing it, then loading the terminal and indexing it again. Or you tell me, because it was definitely seemed like it took twice as long to go through the process. You know, we didn't see the loading screen for 10 seconds, and it took 10 seconds. That's my assumption. You tell me if I'm wrong. What do you think? Let's see what it says. One step closer. We're one step closer. Because we have actually loaded the entire 5 gig file. And even 23 seconds is reasonable if we're not using like 50 gigs of memory. But still, it's too long. It's too long for me. Oh, look, everyone. If my mouse will respond properly. Man, I need to fix this. Wide mouse coming my way. Look. It said, you're absolutely right. You know what that means? It means... We're absolutely right. It's loading it twice. Just feel it. I can smell it. I know it. I knew it. The first 10 seconds, first of all, we're doing it in view. We build the index in 10 seconds. And then we do it again in 10 seconds. And that's why it appears to take twice as long. And that's why we see nothing. We see the log entry, actually. We see the log output for 10 seconds. And then we see the terminal TUI boot up. And then we see the spinner. All right. We should move the pre-indexing. Yes, we should, mate. Because we don't need to do it twice, do we? We only need to do it once. All right. Actually, I realised I've got the wrong terminal up here. Sorry, I'm still getting finding my feet with all of this. They're absolutely right. Absolutely right. My phone is buzzing it again. Someone is buzzing me, or something buzzing me. I think it's more LinkedIn. More LinkedIn. All right. See, this is we were doing it twice. And the 2 launches. So now I'm going to rebuild braid. I go back to the other terminal, the one I was already on, and we'll get the hang of this. And we'll quit, and then we'll clear, and then we're going to rebuild, and then we're going to rerun it again, and it should load. If this happens, if the spinner appears right away and 10 seconds later the list appears, we are golden for the day, and we've got exactly what we came for. Ah! Bit longer than 10 seconds, isn't it? 13 seconds. Okay, well, that's it. That's a 5 gig file loaded up in 13 seconds. To index it, $70,000 requests and responses. Click any of them. Instant loading. Oh, yes. Yes, my son. Yes. Well done, Claude. This was a loaded 5 gig in 13 seconds. It's fully indexed, and we can now navigate to any single one of them. We'll be able to add searching in there, all kinds of fun features, and it will load straight up. That's 5 gigs in 13 seconds. I think that's okay. I'm okay with that. We can't make it any faster right now. And 13 seconds to get 5 gigs of data loaded up and scrollable. We can just scroll and scroll and scroll and scroll and scroll and scroll. And there's just, look at this, ladies and gentlemen. Exactly what we wanted. Click any of them. And there it is. All right. I'm happy with this. Last port of call for the day is going to be to run the performance code reviewer agent to clean this mess up. It's not a mess. It is a bit of a mess, probably. It's not right. There's lots of work to do tomorrow to start massaging this into something that looks a lot nicer than that, for example. And to start to put some more structure in here, and then we can start looking at the mocking capability and setting up a test rig to capture a HAR, and then have that replay and figure out how we can test this. I don't know how we're going to do it yet. We might have to use Playwright or something. I don't know. We're going to figure it out though. We're going to figure it out tomorrow, or Monday. I don't know. Maybe Monday. Tomorrow's probably going to be a visual day. Tomorrow's probably going to be. We'll do some creative work in here and make this look and feel a lot better than it does. But for day 2, we've got a high performance parsing engine now that works for real, that actually works, that does what it's supposed to, and it's clean. And we have the foundations of our TUI, and let me just run that again. I just want to run it again and see the load. Look at that. Looks crap. It looks crappy, but it will look better. It will look better tomorrow. It looks rubbish right now, but we'll get there. We'll iterate. And we'll wait 13 seconds for that 5 gig file, and it comes in. Okay, I'm okay with that. I'm okay with the 13 seconds. I think it's going to be acceptable. And if 10 gig is 23 seconds. You know, I think what we could do actually is we could do a simulation of how long it's going to take if we know that. That's something we can add tomorrow for the indexer. We'll show a progress bar. Ooh, with a gradient in it. Yeah, we'll do that. Tomorrow we're going to add a progress bar to the indexer, and we're going to glamify the actual rendering of the HAR requests and responses. With that, let's go and run the other agent, so we can clean up for the day. We'll come back to our original one, and we're going to do, let's say this. This looks good, Claude. You're right. Sorry, not you were right. I was right. That's not right. I was right. I told you that you were doing it wrong. Anyway, I'm not going to rub it in your nose. Rub your nose in it, sorry. I want you to run the performance-code-reviewer agent to make sure that we don't have any horrible comments everywhere, that we haven't, been violating dry all over the place, and that we have clean, pragmatic code ready for review tomorrow. Let's see. Run the performance code reviewer. It's going to read everything that we've put together so far for the TUI. And when I say TUI, it means terminal user interface, just in case you don't know what I mean. I was calling it a CUI for a while as a console user interface, because they're kind of rare. You actually saw like a surge of them when Kubernetes really became more mainstream, and you needed management tools, but you didn't want a stupid web interface. And so yeah, it's another web interface, and I love web interfaces. I use them all the time, but there's a time and a place for them, and not everything can be done through the web, or should be done through the web. This is like why we spend 99% of our day in a terminal, because it's most effective. For me, it's actually most effective for engaging with this type of technology, is this interface here. It's not inside an IDE. Like, it's part of the problem with IDEs, in my opinion, and JetBrains has a major sufferer of this. Like, if you look at IDEA, and by the way, I love JetBrains. I'm using JetBrains today. Like, I use it all the time, but I can still criticize it. Why not? Because I'm a paying customer. The problem with like these Uber IDEs, like IDEA, which is why they've created all these individual, more focused experiences for different languages and technologies, because like it's like the kitchen sink and everything. You've got access to everything, and every button and dial and knob and combination. I don't want that. I want like a simple, clean interface where I can engage with this LLM, and it can operate tools from the command line. It can operate chat. I can run. I don't know. I don't necessarily have even a great answer. It's just that the experience feels right, and it seems much more engaging when you see I like using like a VS Code plugin for Codex, or even the Claude plugin, the VS Code extension for Claude Code, and there's one built into JetBrains where you can wire them together. I prefer it outside of the IDE, just me personally, and the experience is so much more. You know what it is? Actually, I thought about this. One of the things I love about doing these streams actually is that I'm rubber ducking in real time. A huge revelation for me is the constant rubber ducking, and I prefer. Yes, you can grab. I prefer focused tools for focused use cases. That's why I build what I build and the way I build it. But more importantly, I actually use tools that way. Like I was showing you earlier, I've got a tool for Git. I've got a tool for diffing. I like using this tool for AI. I like using JetBrains for my code. Because I go through different combinations and find like the best that fits in that part of my workflow and the right experience, and I use that specifically. And when vendors build their tools to be individual pieces, that you can use this piece individually as part of your workflow, rather than saying, no, you've got to load us into your megalith or monolith massive, IDE plugins, you need this dependency, and Python comes with it, with all of its other nightmarish things that comes with Python, particularly in the environment. Virtual environments don't solve the problem. Anyway, we're not going to get into that today. I just prefer individual tools. I really do. I like a screwdriver to be a screwdriver. I don't want it to be a screwdriver and a hammer. I don't want it to be a screwdriver and a hairdryer. I just like a screwdriver that screws. And, it's got some nice features on it that make screwing really easy. Great! Not, this is actually a good example of where this can go crazy. And, maybe it's not crazy to you, but I think about the Dyson headphones the other day. The headphones with the air purifier on it. And, just what a horrible idea it is. I can see the practicality behind it. They're thinking of Asian cities where there's lots of smog and smoke and traveling in and out on public transport or on backs of mopeds. You're breathing a lot of crap. You can have music and fresh air, filtered fresh air coming over your face. I mean, that's the theory, right? It's like that's why you would use it. Because it's not like a medical grade device. It doesn't protect you from any kind of viruses or anything like that. I mean, there's still crappy air getting in. It's just like it's slightly fresher air. But what you ended up with is now this like sci-fi looking space helmet that there's an absolute with an average pair of headphones and massive vacuum motors. They put vacuum motors next to the audio drivers for your ears, so you can hear vacuums spinning all the time. Anyway, I'm going off here because that's what you get when you try and jam too much stuff together. It doesn't necessarily need to be together. Just make them headphones, or just make an air purifying mask. But a screwdriver that's also a hairdryer. Just give me a terminal UI. Give me a TUI. Give me a classy looking TUI. Give me a TUI with neon pink and blue, with glows and gradients. That's what I want. We're almost kind of getting there. We're not there yet. We've got a long way to go, but we are making great progress. It's, for me, I know all this code. I understand what I'm looking at whenever I see it. It very much doesn't feel like this is code that is being generated for me, which I'm just like, I don't know what it's doing. It looks good. In you go. It's like, I know all of this, well, maybe you don't know, but I can read it. It feels much more like it's an assistant. I have an assistant here that's helping manifest what I want to see. I know what I want. I know how I want to work. I know what I want, what elements I want to be in there. I know the mechanics of how I want it to work. I know the physics. I know the design of the engine is already there in my head. But using my voice, just using my voice, I'm able to manifest all of this. Now, I haven't typed a line of code. And here we are. We already have at least 50 to 60% of the application built. That's an amazing power. That's the real power of AI. We can just use our voice. And it's building. The cost, well, maybe is there a cost? Maybe the problem, or no, it is a cost. The cost to entry to do it at this level is years of experience. I know how to do this manually. I can do this stuff manually. I have done it manually. It's all live. You can see it now. But I can do it way faster. I can do way quicker and way more with these assistants, these agents that, are very super eager, highly intelligent idiots. And as long as you remember that and you treat them with respect in the fact that they are intelligent, but they're also stupid, and you put rails out for them, they will run along the rails pretty well. It's just knowing how to lay the rails, it's knowing where to put the rails, it's knowing how to bend the rails. And you can only get that through hard-won experience, through just failing over and over and over again. Years of it. And learning what not to do, and where you get burned continuously. How to avoid those traps in the future. Well, right now, the performance code reviewer is no doubt told us to make a whole bunch of changes because there's going to be a lot of crap in there. There's going to be a lot of drive violations. All the things I told it not to do, it would have done anyway. And now is the test to see, once we've asked our code review agent to review the code and then, you know, clean it up, whether it still works. And this is a 50-50. This is a 50-50 shot that is going to absolutely blow something up. What we have is a working prototype with sloppy code. We've asked it to clean the code up. I can feel it in my bones now. It's gonna blow up. And we would have made a bigger mess. A smaller, cleaner mess is a better way to say it. Yeah, there's a great comment in the chat about, you know, AI being a tool, and 90% of it, depending on the human, will result in the nice stuff or being a junk. It's a nice metaphor they're using, carpentry and tools. You know, you can give them tools and saw them wood, but, you know, will they build something good? It depends on the skill of the carpenter. I agree. It's a tool. It's a great tool. It's a very powerful tool. It's definitely turbocharged my output for sure. Turbocharged is a good way to put it. Yeah. All right, we are closing in here. We are closing in. Closing in. This is another trap that I fall into a lot, is that I feel like I'm trying to wrap up for the day. I'm trying to, like, I've done this. We got to a point where it's working. Let's clean things up. And then let's, you know, go and rest ourselves. Rest our brain, get ready for the next day. And take care of all the rest of life things that happen. But then, like, this process here, that 50-50, it breaks. And then you get stuck. And 2 hours later, you're still rabbit holing. No, go backwards. No, stop it. What are you doing, in that case? And, you know, it will eventually fix it, but it can add hours to the process. What it's doing here is he's just using some of those rules from the agent about stupid comments. Stupid, obvious, pointless comments, adding nothing but visual noise and bulk, really. It's cognitive load. That's all it is. Strings imported and not used. So we're in the final stretch of cleaning this up. Let's try the final stretch. Just building it now. Building, testing. Failed to launch the TUI. You cannot run that TUI, mate. This is something I need to do, is I need to figure out what I need to do to give Claude access to a terminal, like via Tmux or something. So it can actually run the terminal, because it can't do it right now, because it's not a TTY. Well, let's try. Let's go over here. Let's go back to terminal 2. I'm going to try, because I've got a feeling it's done now. Let's go build. It does build. Let's rerun. Ooh, it's doing exactly what it's supposed to. It's still working. It's still working. Oh, it still works. Great. All right. Okay. And Claude is telling us that. What did it do? fixed a couple of critical fixes with the viewport settings. That is extensibility. We were going to get into responsive design tomorrow. I don't care about it today, but we need to make sure that we have support for it. Responsive design means being able to shrink and grow the terminal and have it respond in a meaningful way, which means rendering it out at different column widths, which means detecting the column width and re-rendering the terminal in a different way. If you've seen vacuum, if you shrink it down, you'll see it actually restructure how it outputs everything at different widths. Whilst that's kind of automatically handled with a lot of the bubble tea stuff, you still need to be aware of it and put in, at least some logic for it. Removed most 90% of the obvious comments, and we fixed all the unused code and error wrapping. It's now clean and performant and ready for review. Okay, that is tomorrow's gig. We're going to commit this code. We've got our, let me bring up Tower so we can see doing that. All right, so we got our launch TUI, and that was fine. We looked at that the other day. Our view, okay, that's just what that's done is deleted all of that stubbed out code that was just rendering out the statistics of a half hour. We never actually even run that code. We never even saw it running. Who cares? We didn't need it anyway because it was a bunch of filler code. We've got our updated go.mod and the go sum. We don't really care about that, but the go mod is important. I will see you tomorrow, James API. Thank you for tuning in today. We will be online at 8:30 a.m. Eastern, and that is 5:30 a.m. Pacific. And not go to work, definitely not. Oh, we've got a whole TUI in here, yeah. All the TUI, not go work, not some. I've got the view. Okay. Completed TUI build and CLI build for day 2. The TUI now operates as designed. 5GB file loads in about 13 seconds through local testing. The TUI loads, you can scroll through all the results and you can see the request and response loaded on panels on demand. Lots and lots of work to be done on the visual aspect and lots of features still to build, but the basic mechanics are in place now. Okay. Gonna commit that. I'm gonna push that. And then it's I'm gonna come back. Terminal 1. Terminal 1, I feel like a train station. Terminal 1. Terminal 2. Ready for departure. Well, that's it. Thanks, everyone. You can go to github/pb33f/braid and take a look at all the work we've done today if you're interested. Or not. It's up to you. Thanks for watching. Thanks for tuning in. As I said, I'll be online tomorrow, streaming 8:30 a.m. Eastern, 5:30 a.m. Pacific, and a whole variety of time zones across Europe whenever they are. Thanks for watching today. Really appreciate it. It's been great. Until next time. Well, until tomorrow.